दूसरा वाला पता नहीं कहाँ है। Ruchika ma'am, good morning. Participants, am I audible?
Yes, ma'am. Yes.
Yes, ma'am.
Yes.
Ma'am, audible.
Okay, thank you. Good morning, ma'am. Yes. Okay, ma'am. Ma'am, shall we start?
Good morning, ma'am.
Good morning. Ruchika ma'am, can we start? Okay, a very good morning to all of you. Ruchika ma'am has joined us, and good morning, ma'am. I wholeheartedly welcome you for this morning session.
Good morning.
Yeah, thank you so much, ma'am. Earlier, I was not able to hear your voice, I guess, because of certain technical problems. So, thank you so much for joining us today in the morning. Uh, let me say a few lines about you. Although I have read on the internet, you have got a big profile. I request all the participants to kindly mute themselves. Thank you. Dr. Ruchika Malhotra is Associate Head and Associate Professor at the Department of Software Engineering, DTU. She was awarded with the prestigious Women Fellowship for pursuing postdoctoral research. She earlier worked with Indraprasth University, Delhi, and she has received her master's and doctorate degree in software engineering from University School of Information Technology, Indraprasth University, Delhi. And she has received IBM Faculty Award in year 2013. Her H index as per date is 29, and she has more than 2325 citations. That's a huge number, ma'am. And she has got a large number of publications in good research, international journals and conferences. Her area of research is in software testing, software quality, statistical prediction models, software metrics, and validation of software metrics. So it's our pleasure, ma'am, to have you today in the session. So I humbly request to start your session, ma'am.
Yeah, thank you so much. Am I audible? Can I
Yes,
start with
ma'am.
that? Yeah.
Yes, ma'am.
So, a very good morning to all of you. So, today I'll be speaking on the topic empirical software engineering, analyzing experimental data and future directions. So, thank you so much for introducing me. As already Namita has told that I am associate head and associate professor in Department of Computer Science and Engineering, Delhi Technological University. Apart from that, I am associate dean in industry and research development in the university. So today, basically, I will be as this FDP is upon software engineering and application of machine learning in software engineering areas. So I'll be focusing on how to go about in empirical research in software engineering, and what are the future directions that I may be able to give you if you want to pursue research in the area. So before I begin, let me introduce you to the research group we had at Delhi Technological University in empirical software engineering and purposely in machine learning. So myself and Professor Yogesh Singh sir, we are the research guides working in the area, and the research team is endless. We have many MTech students, bachelor students, and you can say doctoral students, postgraduate students who are working in the area. So before I begin, let me start with what is empirical software engineering. So empirical software engineering, when we talk about it, is an area of research that particularly emphasizes on the use of the application of empirical methods in the area of software engineering. So when we apply empirical methods, empirical techniques in the area of software engineering, it's known as an area of empirical software engineering. It involves methods that can be used to evaluate, that can be used to assess, monitor, predict, control various artifacts that are produced during the development of the software. When I say artifacts, I mean whatever is delivered to the customer, whatever is produced at the end of the software development life cycle, such as software requirement specification documents, software design documents, source code. So all these are artifacts that are produced over time at the end of each phase of the software development lifecycle. Basically, in this area, we apply quantitative methods, quantitative techniques to software engineering phenomenon, so that we can understand the development of the software in a better manner, in an efficient manner. Now, coming on to data science for software engineering, it involves various steps. First, we need to understand the problem. Then we need to have data. So today I will introduce you how to collect data in software engineering, and I'll also give you some sites, that means open source repositories where you can get data from. Then the next step is cleaning the data, analyzing the data, followed by developing the model, using various machine learning techniques. When I say learning techniques, I mean that I may use statistical techniques or machine learning techniques or evolutionary techniques. So any kind of learning technique can be used to develop the model. And then comes the validation part, model validation part, and finally the reporting and the discussion. So these are various steps involved in empirical software engineering. So coming on to what are the top journals that are there in this area. So first is IEEE transaction on software engineering, and here comes the impact factor. So what is the impact of the general that is calculated by Web of Science? By considering the past 2 year impact and the publication. So this is 4.7 about. And then comes next is empirical software engineering journal that is published by Springer. It has 4.4 impact factor. So there are many. The list is endless. So few of the ones I have listed. Then we have advances in engineering software, IEEE software, IEEE transaction on reliability, information systems, requirement engineering journal, software quality journal. We have information in software technology journal. We have journal of system and software. We have ACM transactions on software engineering. So and the list of top notch journal in the area is endless. And these are few ones that I have listed for you. Now, before we begin in the to understand various concepts, let's try to understand what is an empirical study. So, when we say empirical study, it means we are attempting to compare the theories and observation using real life data for analysis. So, when we use real life data for analysis to compare the theory and the observation, it's known as an empirical study. It utilizes various data analysis methods and statistical techniques for exploring relationships. So, various analysis methods means machine learning techniques, statistical methods. So, they are used for exploring the relationship amongst various concepts. Now, let me introduce you to what is the process. So, it's very important as a researcher to understand the process of experimental study, to understand the process of an empirical study. So, it's a 5-phase process. So, I will explain each and every step in detail before we begin and we go in detail into the directions that I'll give you in the area. So, first is study definition, and side by side, I'll keep on telling you how to collect data, how to form hypothesis, how to identify variables, how to go about selection of a machine learning techniques, and so on. So every step involved in the empirical study, I'll keep on explaining each and every step to you. So first phase is study definition. So in study definition, we define the scope. What is the scope of the study? What is the purpose, motivation behind the study? What is the context for whom we are carrying out the study? What is the target or audience? So this is the first phase in an empirical study, where we actually define the scope, the purpose, the motivation behind the study. Then comes the experiment design. In experiment design phase, we form the research questions, we form research hypothesis, we define variables, we identify variables that are involved in the research experiment. Now we select an appropriate machine learning technique. We identify what may be potential threats to the study. So limitations of the study. What are potential limitations of the study? So in this phase, this is a very significant and important phase in empirical study. Then comes the next phase, where we conduct research by summarizing the data, by minimizing the attributes, by applying various statistical tests, and then interpreting the results and so on. And then comes the next phase, where we interpret the results in the theoretical practical significance of the results, and we report the limitations. So here we have identified, and if they have been removed, then we will not report them. But if there are some limitations that exist, we need to report it. And then finally presenting the results. So presenting the results may vary. It depends upon which venue you want to present your results. If it's a research project, you may summarize it in form of a report. If you are a PG student, you may summarize it in form of a thesis. If you are a master's doctorate student, you may summarize it in the form of thesis. If you want to publish it in a journal, you may summarize it in the format of the journal as a journal article. So if you want to publish it in a conference, you may make it in the form of a conference article. So it depends what is the venue of the publication of the paper. So the study you are carrying out. So let's now begin phase by phase how to carry an empirical study in the area of software engineering. So the first step is the first and foremost step is the definition of goals and objectives of the empirical study. So this phase is divided into various aspects. So first you need to define what are the dimensions of the study, what is the scope of the study, why I am studying this, what is the reason behind, what is the motivation behind, even whenever we get reviewer comments, the main comment comes at what is the novelty in the study, what is the why are you carrying out this study, what is the motivation behind the study. So that is the prime question that is asked by the reviewer too. Then comes what entity is being studied. So what is the object that you are studying, what is the entity that you are studying in your work, whether it is a process or a product. When if we talk about software engineering, then comes what is the purpose, what is the aim of the study. Then from whose perspective the study is being carried out, from the project manager's perspective, from customer's perspective, from developers perspective, from a tester's perspective. So from whom's view point of view are considering when you are carrying out the study. And then comes what is the domain of the study. That means what is the area of the study, what is the area that you are main area that you are studying. So all these questions need to be answered, all these issues need to be addressed in the first phase. So whenever we think about carrying out a study, we need to identify all these parts and answer first all these questions before we begin on carrying out our research work. So next, as I have told you, it's the very important and significant phase. So experiment design is an important and significant phase. The design of the experiment, it covers various parts concerning about carrying out the research question. So what do I need to inquire from my study is answered in the first part in form of research questions. That what do I need, what I am evaluating, what answer I'll obtain at the end of the study. Then I need to formulate my hypothesis. Hypothesis means assumption of my research. What is the assumption of the research? Then I need to identify variables that are involved. So independent variables, dependent variables, input variables, output variables, predicted variables. So all these variables these are synonyms that we use for variables. So you need to identify them. Then comes very important part when we talk about software engineering. How will we collect data? From what will be my source of data collection? And then finally I will select an appropriate machine learning. So there is also disciplined phase wise way in which we select a machine learning technique, and I will introduce you to what is the right way of selection of a machine learning technique. And then comes the context of the study. So in this particular, after this, the context of the study is defined. So these are some steps that I have listed for you. First is that we identify goals and research questions, and that means you are in the phase of understanding the problem. Then we carry out a exhaustive literature review. Carrying out exhaustive literature review means that you search through various digital portals. For example, IEEE digital portal, ACM digital portal, Wiley, Science Direct. So all these digital portal you search and you find the paper that are very closely related to your work, and you then critically analyze those publications and see what already has been done and what needs to be done for further improvement. So the aim should be you should contribute something to the area, you should contribute something to the society, you should contribute something to the the academic world. So this should be your aim when you do this critical review. Then comes the next phase where the hypotheses are formulated, the important variables in the research are identified, and then you collect data. And how to go about it, I'll explain you. And finally, then you select the appropriate machine learning technique by some logic. There must be some reason why I am selecting machine learning technique A, B, C. First step, let's go step by step, is formation of research questions. So the first step in the experiment design is to formulate the research questions. This step states the problem in the form of questions and identify the main concept and relations to be explored. So basically, the main relationships that I need to explore in the experiment design. The experiment study is identified here. For example, what is the effect of software measures on faultiness of a class, faultiness of a module. So I may form this research questions. And what will be the effect of various measures in the when I say software matrix, I mean I am measuring, for example, size of the software. I want to measure how much coupling is there in the software. I am measuring how much cohesion is there in the software, how much any inheritance is there in the software, and I relate these measures with the faultiness of the class, how much the class is fault prone. Now, whenever you form a research questions, you need to keep three things in your mind. First is, what is the existing relation to the literature? So the research question you form, how it is related to the earlier work. What are methods, data collection techniques, machine learning techniques that must be used to? So what will be required to answer these questions? And the most important thing is, what are you contributing to the area? What new thing you have, new fact you are trying to prove? What new thing you are contributing in the area of research? So the next step involves that is to review the literature. So extensive literature review is involved. A literature review identifies the related and relevant research and determines the position of the work in the specified area. So you need to identify what are the key theories, concepts, and ideas. You need to see what are the academic terminologies and information sources. You need to see what are the key questions that have been addressed till date. What are the areas in which authors have different views? So you need to see what are the areas in which authors have contradicting views. So by a literature review, you need to identify the gaps. This is very important, that you identify the what are the key areas where knowledge gaps exist. You identify the gaps in the in the area. What are the major issues and controversial topics? So what are controversies involved in the topic? So you need to see that. What have been various methodology that have been used, and what is the quality of existing research? So what quality of publication, how much time it has been incited, and apart from that, what is the how well the paper is written, how much detail is present in the paper, so that also signifies the quality. What is if you are able to find which techniques have been used, why they have been used, and everything is explained very well in the paper. So it is obviously it contributes towards the quality of the publication. What are the areas on which the further research needs to be done? So finally, you need to see what are the areas where further research needs to be done. So you can do your research, you can say related work survey, or the survey by using various articles, conference papers, technical reports, books chapter that are present. And the major benefit of this review is that the researchers become familiar with the current research. So you know how much has been done, and then you start with your own. Now comes the second step in experiment design, that is identifying variables. Now, before beginning this thing, there are two types of variables in experiment study. When we talk about an empirical study, there are two kinds of variable. First is independent variable, and second type is dependent variable. See, independent variables are input variables. Okay, and dependent variables are outcome variables. So independent variables is a variable that can be changed, that can be varied to see the effect of. So what do we want to find? We want to analyze the effect of independent variables on the dependent variable. For example, let's consider weather data problem. So whether if I want to identify, I want to detect whether today it will be rainy day, I want to predict whether it will be a sunny day, cloudy day. So I can have various independent variables that can help me. For example, temperature, pressure, humidity. I can use these variables to identify my outcome variables. So temperature, pressure, humidity, these will be my independent variables. And my outcome variable is the type of the day, whether it's a sunny day and with various categories. So the outcome variable has various categories: rainy, sunny, cloudy, windy. Okay. So there is one dependent variable, and there can be multiple input variables. So what I want to analyze is, I want to analyze the effect of all these independent variable on this dependent variable. So how these independent variable are related to the independent variable. So I want to establish a relationship between them. So there are two types of data. One is discrete, and that is also known as non-metric, and other is continuous. Discrete type of data is of categorical in nature. So it either can be nominal or can be ordinal. Ordinal means that there is some order involved. For example, I say a class is class has high number of faults, low, medium number of faults, or low faults. So it is the data is categorical. That means it only has three categories, but it has some order. High is greater than medium, medium is greater than low. When I say uh, whether the fault is there or not there, 1 or 0, yes or no, so it's nominal. That means there is no order there. So categorical type of data can be defined into two categories. One is ordinal and another is nominal. Then we have continuous. Continuous type of data represents amount of magnitude, such as lines of code. Now, how do you go about selection of attributes? Selection of attributes means selection of variables. So variables are synonym. These two terms are used interchangeably. Variables and attributes. So you can either do based on your past experience. So you already a established researcher, or you have done a research, similar kind of research before. So you know what type of variables will be there, or you can gain information from the published area. So already you have published research, so you can gain information about the variables in that research. You can take advice from experts. So there are established authors who are already experts working in the area. So you can take their advice, and you can identify the important variables. So let's consider a small example. Say there is a playground next to our house, and for the past 2 weeks we have been observing that there were kids who have been coming and playing in the playground. So while observing, we have noted when they come, what is the time, what is and in the playground, on when they don't come. So based on the data you collected, you would like to predict if kids will be playing on playground on a specific day or not. So what data would you collect to decide whether the kids should play on the playground or not? Can anyone switch on his or her mic and answer this question? So what data would you collect to decide whether the kids would like to would play on the playground or not on a specific day? Can anyone identify the variables involved in it?
And it could be weather conditions,
Yes, it could be weather conditions.
temperature on a specific day.
Yes.
Ma'am,
Whether it's
weekday or
holiday,
weekend?
it's weekend. Yes, weekday or weekend. Yes. Any other input, if anyone can provide? Okay, so there are various factors that can contribute. What is the time of the day, for example? It's afternoon, it's evening, it's morning. Okay, or whether it's weekend, it's weekday, and whether it's exams are going on, they're not going on. And apart from that, there are other variables. For example, forecast. What is the forecast? In the evening, there is going to be rain, so you'll not send your kids to play. What is the kind of temperature? It's hot, mild, it's cool. Humidity, it's high, it's normal. So based on these are known as independent or input variables: forecast, temperature, humidity. And this is your output variable, whether you will send your kids to play outside or not, yes or no. So it's kind of nominal variable, yes, no. So we'll send them or not send them. Now coming on to the next part, after we identify a variable, so in the similar way we identify variables in the research. So after identifying the variables, we come on to the hypothesis. We need to form the assumption of the research. We need to state the assumption of the research. So the main objective of an experiment usually is to evaluate a given relationship or hypothesis. So you need to evaluate what is that particular hypothesis is going to, you will evaluate in your research. You will either prove it or disprove it. Hypothesis, it's a formal statement that presents the expected relationship between the independent variable. So it formally defines the relationship, the expectation out of the study. The researcher should carefully state the hypothesis to be tested in the study. So the hypothesis tested on the sample data. So the data you collect, that the hypothesis tested on that sample data. On the basis of the result from the sample, a decision concerning the validity of the hypothesis is made, whether it is accepted or rejected. For example, for each method M, each technique M, the hypothesis in this study is the following. The relevant null hypothesis is given in parentheses. So when we talk about hypothesis, we define two things. First is null hypothesis. Null hypothesis is always the one the researcher want to disapprove. The researcher always wanted to reject that hypothesis. And alternate hypothesis is the one that the researcher always want to accept. So our aim is to prove the alternate hypothesis. The relevant null hypothesis is given in parentheses for the capital H, which indicates the hypothesis. So I say the method M. M means maybe random forest. So it outperforms the compared methods in predicting fault-prone software classes. So this is example I'm giving you for the hypothesis. And my null hypothesis will be that M does not outperform the compared methods in predicting fault-prone classes. So this is my alternate hypothesis. So let's consider an example. I have a research assumption that girls will achieve higher reading comprehension test scores than boys at the end of the first semester. This is my assumption of the research. So how I will represent it in the form of hypothesis? I will state the null hypothesis that there is no difference between the two means of the girls and boys on the reading comprehension test score. So there is no difference. And what is the alternate hypothesis that I want to prove is that the girls' mean score on the reading comprehension test is significantly better than, it significantly exceeds than the boys. So this is my, so this is the way in which I have represented my assumption in the form of hypothesis now. First alternative and then null hypothesis. After I have, stated my hypothesis, the next very important step is collecting data. So empirical research involves collecting and analyzing data. Data collection needs to be planned, and the source from which the data is to be collected, it needs to be decided. So the researcher should state the environment in which the study is being performed, the programming language in which the systems are being developed, the size of the software, the duration for which the software was developed. So broadly, I can define that there are three, potential, you can say, ways in which I can collect data. I can collect it from student software, so from academic. It's the easiest way of collecting data. I can collect it from industry. I can go to the industry and I can request them to give me proprietary data because it's their copyright on the data, so they can donate me, they can share it with me. Or another thing is that I can use open source software or open source repository that are freely available to collect data. So these are three ways in which data can be collected. So the first way, these days we don't prefer. In initial days of empirical software engineering, when the research we used to do, I think well in 1990s we used to collect data from this. Yeah. So Bryant was the one who used to carry out empirical studies, and Bryant, and I think that then he used to collect data from various software data that were developed from students. But see, there are various threats involved in it. The students are inexperienced. They don't use ideal methodologies. They don't follow coding standards, coding practices. So collecting data from there may produce, unrealistic results. Right. So it's it's easy way to collect data, but it has many threats involved. Then comes, the second venue from where the data can be collected, that is the industry. It's very difficult to get data from industry. We want to collect data from industry, but it is very, very difficult to get data from industry. Then come the open source repositories. So these days we prefer to collect data from open source repositories. So it's the easiest way, no, I will not say easiest, but yes, it's a compromise between academic and industrial data. We can collect data from there. So this is the third way in which we can collect data. So whenever I do now, I do research, I collect data from open source repositories, from maybe Android software, from Apache datasets. So there are so many open source software that are present, so we can collect data, and it will be closer to the industry. They are closer to the data. The results will be produced will be closer to the industrial environment. In India specifically, I have seen very less tie-ups that academicians have with the industry for data. When I was in Finland, I found that they have very strong tie-ups there and for collecting data, because we always want to get data from industry. But due to their heavy, restrictions, their privacy conditions, it's very difficult to get data from there. So academic data developed by student programmers is generally small and developed by limited number of developers. These days, open source software repositories are being mined to obtain research data for historical analysis. In practice, obtaining data from proprietary software for research validation is difficult as the software companies are usually not willing. So they are not willing to share their private information. So that's you can say a drawback in Indian context, and that the industry doesn't trust the academicians. But we need to bridge that gap. I don't know when it will be bridged, but we need to bridge that gap between the industry and academia. Now, next very important thing is how to go about selection of an appropriate machine learning techniques. There are so many techniques we have in the literature. So how go about selection of these techniques? So first is obviously we there are few techniques that are applicable when the dependent variable is continuous, and few techniques that are applicable when the dependent variable is discrete. So we can easily categorize techniques. For example, linear regression is applicable when the dependent variable is continuous. Logistic regression is applicable when the dependent variable is kind of categorical. Then an appropriate data analysis technique should be selected by identifying its strength and weakness. So we need to analyze the weakness and strengths of the a particular technique in the in context of our problem, and then we should go about selection of a technique. We can select the most appropriate method by comparing different parameters and properties of the various techniques that are available. So these are broadly three criteria for selection of an appropriate machine learning technique. First is type of dependent variable. If it is obviously, few techniques are applicable when the dependent variable is categorical. Few techniques are applicable when the dependent variable is continuous. Then it depends upon our data set. If some technique is parametric, there are some assumptions that need to be satisfied before we apply that technique. Then obviously we need to satisfy those assumptions. Then I need to consider important aspects of different algorithms. So there are various algorithms. I need to consider each and every aspects of that of those algorithms before going on selection of a technique. So here you see, on the basis of dependent variable, I can identify a technique, whether it's binary, it's continuous. So based on that, I can identify technique. Then comes the nature of data set. Nature of data set means whether it's normal, it's not normal. What is the size of the data set? What is the diversity in the data set? Whether it's redundant, whether we have missing values in the data set. So one technique may be applicable when you have missing value. Another technique may not be applicable. Deep learning is applicable when the size of training set is very, very large. So it's important to analyze these aspects, the nature of the data set before we begin with selection of an appropriate machine learning technique. Another very important thing is we need to analyze. We should first analyze important aspects of a technique. What I have observed that various researchers, academicians, they select a technique because it's a very popular technique. Maybe, for example, deep learning technique. Each and every person try to apply this technique because it's very, very popular these days, without analyzing whether it is applicable in their case or not. So to select an appropriate technique, we need to analyze the important aspects that should be considered. For example, accuracy. Accuracy is one aspect. It refers to the predictive power of the algorithm. So what is the predictive capability of the technique? We need to identify that. What time, how much time it will take. So if it takes hours and hours, there are some search-based technique which take days and days to compute. So if even we get accuracy a bit better, we will not want to waste so much of time. So it depends upon our priority of our model. Then how easily you can understand it. See, a technique that is a black box for you, you should never apply that technique. First, you should understand the technique so that the results produced by the technique should be easily understood by you. It should be easily interpreted by you. Then simplicity. The algorithm must be simple. So it should be easy to learn, easy to operate, easy to understand. That's very important. So other considerations that you may take into account is if you have missing data, so ability to handle missing data. How much, if you have outliers means value that lie far away from the mean of the data sets value. So it's sensitivity to outliers, accuracy of class probability estimates. So if you have imbalanced data, imbalance means if you have one category of outcome class in majority and other in minority, You need techniques that can handle this issue. Then if you have non-vector data, ability to handle non-vector data, ability to handle high dimensional data. So it depends upon your problem. First, you need to analyze, you need to spend time in deciding which technique and why I am applying that technique in my research. Then what are the various concerns involved in machine learning techniques? First, the data must be pre-processed. It is always advised to pre-process the data. A suitable learning technique must be selected for a model development. A model must be checked for multicollinearity effects. So there may be, if you are creating a predictive model, there must be, one variable that is making another variable significant. So multicollinearity effect must be checked. The training and test data must be as independent as possible, so that you obtain more realistic model validation results. The parameters settings of machine learning techniques may be adjusted and should be carefully documented to produce repeatable results. Now, another concerns are overfitting. So normally, the model overfitting means that the predictive model that you are creating, it learns noise rather than the relationship. When the training error is much lower than the generalization or testing error, the model predicted is said to be overfitted. So that means when you created the model, developed the model, the error was very, very less. But when you validated the model on new data, the error suddenly increased. That means the model has overfitted. It has learned noise rather than the data. The data means the relationships amongst variables. So here you see when the empirical error means when actual values do not match the predicted values. So the empirical error is very, very less and the generalization error is very, very high. Then you say the model has overfitted. Then comes another issue is bias versus variance. So high bias means underfitting. That is, model predicted is too simple to capture the relationships. And high variance means that the model is too complex and captures noise with the relevant patterns or relationships. So we need to obtain a balance between bias and variance. What are the recommended solutions? If the bias is high, we need to increase the attributes. We need to increase the independent variables. When the variance is high, we need to increase the training samples, or we can reduce the number of variables, independent variables or attributes. Then we need to analyze the degree to which the other variables are affecting the variables. For example, A variable is significantly related to outcome variable, but it may be possible that variable B is making that A variable very, very effective. So as the multicollinearity rises, the ability to define any variable's effect is minimized, which leads to difficulty in interpreting the model. There are various methods that you can use to measure this multicollinearity effect. That's what's, for example, variance inflation factor, principal component model, and so on. Now comes dealing with imbalanced data. I told you what is imbalanced data problem. So another problem with model prediction is imbalance. So imbalance means when you have, it's a very upcoming area of research in software engineering. When the data set is one type of outcome class having higher instances, majority class, and the other class has minority class, instances. So, for example, I have outcome variable, the playground example that we have taken. So, number of, for example, I had 100, training samples, and out of that, 80 had value no, and 20 had value yes. That means that no is in minority, and yes is in majorities. That's the data imbalance problem. So when a model is developed with imbalanced data, it tends to be strongly biased towards the majority class. So it will be very, very biased towards the instances that are in majority outcome, the instances of the outcome category, as the machine learning technique tries to maximize the prediction accuracy of the model. So there are various ways. So it's an upcoming area of research. There are various ways to deal with it. You can use oversampling, undersampling techniques. You can use cost-sensitive learning. You can use appropriate performance measures to deal with this problem, and so on. Then another issue when you talk about machine learning technique is parameter tuning. So you need to appropriately tune your parameters before you begin on your research, applying that particular technique on creation of the model. So neither you should undertune nor you should overtune. This is the rule of thumb. care should be taken as over-tuning the parameters of a technique leads to biased results as the technique overfits a specific training and testing data. And I told you the last step in experiment design was identifying potential risks, potential threats, potential limitations in your, in your study. So that is another step. So a validity threat is a specific way in which you might go wrong. So there are various types of validity threats that may be present. Then you need to also identify mitigation of threats. How will you remove these threats in this study over time? So these are various categories of threats, either internal validity threat or external validity threat. Internal validity threat means it's related to some internal concept. For example, I have measured coupling and it is not been measured properly. So it's an internal validity threat that my data consists of some independent variable that has not been measured properly. And if I say my results are not generalizable, that means I have collected data from a software that is being developed in Java. So it will not be applicable on those software that are developed in C++ or other languages. So that is my external validity threat. So whatever type of threat you have, you need to list it down. So then comes the next phase, the third phase in empirical study, that is research, conduct, and analysis. So finally, the empirical study is conducted following the step described in the experiment design. The experiment analysis phase involves understanding the data by collecting descriptive stats. The unrelated attributes are removed and the best attributes are selected out of the set of attributes using attribute reduction techniques. So after removing irrelevant attributes, hypothesis testing is performed using statistical techniques, and on the basis of result obtained, a decision regarding the acceptance or rejection is made. So these are the steps involved in predictive model creation. First, you need to summarize the data by using measures of central tendency and measures of variance, descriptive stats, mean, median, mode, standard deviation, variance. Then you need to do outlier analysis. You need to find those data points that lie very far away from the mean because they will significantly affect the results. So as a researcher, you need to analyze whether I should retain them or I should remove them. For example, weight of a particular student is 170 and rest of the students lie between 60 to 80. So it's an outlier. It may be that it was 70 due to typological mistakes. I typed it 170. So I need to then remove it. I need to analyze why this outlier is present in my data. Then correlation analysis. I need to correlate the variables and find the relationship amongst them. Then next step is attribute reduction. See there are two types of attribute reduction techniques. Either I can select important attributes. So I need to remove the irrelevant, the redundant attributes in my research. So the attributes that are non-relevant, that are repeated, that are not required, I need to remove them. Then comes hypothesis testing. So I can apply parametric and non-parametric. Parametric tests are those tests that have some assumption that the data should be, for example, the data should be normal if I want to apply t-test. And there are few tests that are non-parametric. That means they are not based on, they don't require any, any assumption. So there is no assumption, you can directly apply them. Safest way. And then you need to analyze identify the performance evaluators. How will you evaluate the performance of your model? So there are various recall, precision, accuracy, area under the curve, G mean, G measure. So balance, which measure you will apply. You need to decide before you go on to model development. Then you develop the model using machine learning or any statistical technique. And finally, you validate the model and then you apply model comparison tests to see whether a particular model is better than another model or not. The first part is dividing your data into two parts. So when you think about executing your study, you divide your data set into two parts. First is used for training and other is used for testing. Then you select relevant attributes, you remove the irrelevant ones, and then you develop the model using machine learning techniques. And finally, it's validated and the results are interpreted. Independent variables, also known as attributes, are reduced using attribute subselection techniques. So there are various subselection techniques. You can use those techniques. Then after the data has been partitioned, the next step is to train the model. So you need to train the model using the machine learning techniques that you identified in the previous phase. The model created in the previous step is then validated. The performance analyzer that you are selected depends upon the type of the dependent variable, nature of the dependent variable. Then you can apply cross-validation technique, inter-project validation technique, inter-release validation technique for validating the model. What do you mean by cross-validation technique? So the ratio in which you divide your data set is decided on the base of cross-validation method. So first method is holdout validation. That means you divide your data into two parts, maybe in the ratio of 60-40, 70-30, 80-20. The bigger part is used for training and the other part is used for testing. But it is only suitable when you have large size data. Then comes next type is type of validation, cross-validation technique, that is K cross-validation. That means you divide your data into K parts. The K-1 parts are used for training and the 1th part is used for testing. And normally in research, K is equal to 10. So this particular technique is used when you have medium-sized data set. Leave and out is used when you have very, very small data set, 20 data points, 30 data points, 40 data points. And then K is equal to 1. That means then each time you can say sample is used for testing and other all samples are used for training because the size is very small. And apart from this, see, in this cross validation can only be applied when you are using the same data for testing and validation. But nowadays we have shifted. I'll soon share with you the future directions in which I'll tell you that normally we now apply cross-project validations, inter-release validations, inter-project validations, where we use project A for training and project B for testing. Now you need to identify you can say performance analyzer. So it depends upon your data, your dependent variable. If your dependent variable is categorical or binary, you may use sensitivity, specificity, accuracy, precision, recall, or G measure, G mean, area under the curve. If your dependent variable is continuous, you may use correlation coefficient, mean absolute relative error, mean relative error, and so on. So all these you must be aware of these facts. Now, next step in research, after you have now you have your results with you. You need to interpret them. In this step, the results computed in the empirical study analysis phase are assessed and discussed. So the reason behind the acceptance or rejection of the hypothesis is examined. The conclusions are derived from the results obtained. So basically, you interpret the results. What is the significance of the result? You either accept the hypothesis or reject the hypothesis after this. So what are the issues that need to be addressed when you interpret the result? First is, does your result support the research hypothesis? It means the hypothesis means the assumption of your research. You said, for example, you said that girls will perform better than boys in English test. Whether your data supported this particular hypothesis. Who will be benefited by the results? So what was your target audience? You need to write down here that these are the people who will benefit by the research. You need to list down, when you interpret your results, you need to list down that some limitations that you identified in experimental design phase, you must have mitigated them, you must have removed them, but few might exist. So the one that exists, you need to clearly state here that these are the limitations. Then how does the study relate to past studies? Important thing is how your study relates to the past studies, and what are the lessons learned from the study. That is important. So what lessons did you learn from your by carrying out the study? So when you interpret your results, you keep in mind all these things that yes, I will answer these things when I'm discussing my results. Now, presenting data, either you can present the data in form of you can quantitatively in form of charts, scatter plots, tables, or you can you can interpret it in the form of a text. You can write down the various things in form of textual thing. So this is very important. Drawing conclusion from hypothesis. Obviously, as a researcher, I always want to reject the null hypothesis, and I always want to prove my hypothesis, that is the alternate hypothesis. but it may not be true all the times. It depends. My data may oppose what I am assuming. So when the null hypothesis is not rejected, it doesn't necessarily mean that there is no difference among the two techniques or two methods. It means that there might be difference, but it is not detected by the sample data. So there may be the concept may be true, my assumption may be true, but that means my data currently is not supporting that concept if the null hypothesis is accepted. When the null hypothesis is rejected, that means that there is a statistical difference that has been obtained in the results. And however, the researcher need to decide whether it is of practical significance or not. Now, last step in the empirical study is now reporting the results. So finally comes the step where we need to present the results in a desired format, in the form of a report, in the form of a project, in the form of a thesis or a research paper. Depends upon your venue of publication. Now, see, before I wind up the procedure and I begin with the future directions, ethics in empirical research, this is very important. Because if I get data from industry, if I get funding from third party, I need to follow all the ethics very strongly. So I need to be ethical. I need to conduct the research by following all the ethical standards. For example, if I have collected the data from industry, so I need to hide the identity of the participants. I cannot disclose it. Then comes your plagiarism part. IEEE defines plagiarism as the reuse of someone else's prior idea. So whenever I go to any program, I always emphasize on plagiarism because it's very important issue these days. So IEEE, ACM, in fact, UGC has laid down strong guidelines for adhering to the policy of plagiarism. You must be knowing that UGC has given a guideline to form an Office of Research Integrity these days. So ORI is an important integral part of every university where you see that all the ethical standards are being followed in the research. So IEEE defines plagiarism as the reuse of someone else's prior ideas, processes, results, or words without explicitly acknowledging the original author. So when you do that, it's known as you have done plagiarism. Even paraphrasing someone else's work is plagiarism. Even copying your own work is known as plagiarism. So ICM, IEEE, you can go through these guidelines. They have given very serious actions against authors, and UGC also has given very serious actions that will be taken in context of students and in context of faculty. So when it concerns about plagiarism. So Turnitin is a good source that we have. You must also have it's a proprietary software that is nowadays used by various universities, colleges, institutions for scanning the research paper. Now, as I told you that I'll give you a list of repositories where the data is available. First is predictor models in software engineering, promise data repositories. So real world data is difficult to attain, but if you go to this repository, it has lots and lots of software engineering data. So you can get data from these repositories, data related to defect, data related to text mining, data related to COCOMO or any other, type of effort related data. Everything you will get here. Then we have ISPSG, International Software Benching Standard Group. Here you can obtain data by making some payment. So it maintains a repository of data from numerous organizations, completed projects. So you can get data from here. It gives you data about, project durations, function point structure, cost estimation, and so on. So effort related data you can get from here. Then we have Eclipse bug data. It's again free of cost. You can go through Eclipse bug data repository and you'll get data of all the versions of Eclipse. Now, applications of data mined from software repositories. So whatever data we mine from, I told you how to get data from repositories. So you can use it in predicting defects, faults. Predicting defects means that you want to predict whether a class is going to be faulty or not faulty in the early phases of software development. You can use the data in predicting changes. You can use the data in effort estimation. So these are various applications of data mined. Design correction, change impact analysis, pattern mining, trend analysis. So all these areas you can use the data mined from the open source repository. Now coming on to which possible tools are available for mining data. So there are various tools, you must be aware of them. First is Vekaito environment for knowledge acquisition. This is a open source tool that is available for machine learning with various machine learning algorithms. Then we have Keel. Keel is basically can be used for evolutionary algorithms. It's again a open source software. Then we have SPSS, statistical package for social sciences. So it's a proprietary software. It has various multivariate analysis and statistical testing techniques present there. Then MATLAB is again a proprietary software. It gives you a good environment for developing new mathematical algorithms. R is again an open source software. Octave is again a counterpart of MATLAB, but normally it's very usable in Linux environment. Oh, and then we have Python that is being used. So all these are, these platforms you can use for creating your own algorithms, or they have the, inbuilt algorithms that you can reuse. Now, one by one, let's discuss what are the areas where you can work in software engineering. See, there is a need for more studies to assess and evaluate the performance of machine learning. Machine learning techniques has been widely used in effort and defect prediction. But search-based technique, it's an emerging area. Hybridized techniques is an emerging area in empirical software engineering. And obviously, whenever you use an upcoming technique, you need to compare it with you should compare it with traditional logistic regression statistical technique to show whether it is significant or not. Sometimes I have seen that students do use new techniques, but their results are either they are equivalent to the existing statistical techniques, or they are lower than even those techniques. You need to compare them. Then moreover, in order to assess the true potential of a given technique, machine learning technique, it should be compared with other machine learning or search based technique. Also, the results of a study are effective only if they are statistically assessed. So you need to statistically evaluate the result. Okay, so statistically evaluate means, as I have told you, that you need to test the hypothesis. So you see, if I say a particular technique A is better than technique B, I need to statistically evaluate whether it is better than A, B or not. So if I apply Friedman test, Wilcoxon sign rank test, t-test, so all these techniques will give me a statistical test will tell me whether, if I am saying A technique is better than B, whether it is statistically better than B or not. Then comes the data set should be made available in public. As I told you that data is a issue in software engineering. Since 2001 or 2, I think, when Promise Data Repository came into picture, we have data sets with us. But before that, it was a serious issue getting data. So you should donate the data in public. There are two reasons. See, it's a transparent world now. So if someone wants to repeat my results, so if the data set is present in open source repository, she would be easily be able to repeat the results. Okay, so it should be available in public. In future, studies that explore the effectiveness of various predictive modeling techniques on industrial data sets should be conducted in order to provide practical usefulness of these techniques. So industrial data sets, this is another, you can say, drawback of software engineering research, empirical software engineering research, that we don't still apply industrial data. Then future studies should incorporate a number of other validation techniques which reduce validation bias and evaluate the developed model in real and practical scenarios. So I've told you that the validation techniques are being used, hold out, 10 cross validation. But we need to, move ahead now. We need to, develop a model using different training set and validating on different, totally different validation sets to get actual picture about what is the performance of our model. Clearly, you should specify the parameter values of the predictive model. So the parameters should be very, very clearly defined. So why? Because if someone else wants to repeat the study, if someone else want to replicate your study, he or she should be successfully able to replicate it. Then a predictive modeling technique should be carefully selected based on its properties that I've already told you. That whenever you select a machine learning techniques, you should have a reason why you have selected that technique. While predicting binary variables, future studies should incorporate multiple and stable performance evaluators for developing models, such as area under the curve, balance, G-mean. See why I am calling them a stable performance evaluator. Area under the curve is obtained using receiver operating characteristic curve. So these are the area under the curve is a very stable measure. It's known to be a stable measure, performance measure. So you should use these stable performance measures for evaluating your results. Apart from prediction accuracy, future studies should focus on other aspects of evaluation of data analysis. So such as time, cost evaluation, and other things. Comprehensibility, cost effectiveness, generalization capability. So apart from the accuracy measures, you should evaluate these aspects also when you create models using machine learning techniques. Now, in future, what you can do? In future, researchers and practitioners should develop and establish a number of tools. In fact, we do have machine learning tools, but search-based techniques. Keel has implemented some search-based techniques, but they take many days to execute. So we need tools, good tools for implement search-based and evolutionary techniques. So that is another area of research. So future studies should focus on careful design of experiments by taking into account various threats to validity. So future studies should take into account various threats to validity, and when you design your study, this is important. Such a practice should lead to effective application of techniques for software quality predictive modeling. So while developing your predictive model, you should properly specify the fitness function. So if I am using search-based technique, the fitness function should be clearly stated, and so that is another area of research that we can explore multi-objective fitness functions. They have not been much explored in software engineering research. I'm not talking about empirical software engineering particularly. In other areas, they may be, they may have been explored, but this area, multi-objective fitness functions have not much been explored. Future studies should account for the randomness of. See, search-based techniques are random in nature. They are stochastic in nature. Why are they stochastic in nature? Because the number of times, each time they produce different results. So you should at least execute them 30 to 50 times, and then take average of the results and then report them. So performing more than 10 runs, more than 10, no, I think more than 30 runs should be performed at least. So while comparing two search-based techniques, researchers should perform a fair comparison. Fair comparison means, for example, technique X has scored 6% on accuracy, and technique Y scored 78% on accuracy. But technique X performs a running time is 60 seconds. Whereas technique Y, although there is only improvement in 2% of accuracy, but see, the time has increased. That is 300 seconds. So to really show technique Y outperforms technique X should be at least run 300 given that time that Y has taken. So this is all, but I will like to introduce one or two more things that are new in software engineering field. If we talk about, first is transfer learning. Transfer learning means that you basically it's an application of cross project validation. Transfer learning means that you transfer various concepts. There are various types of transfer learning. It's an emerging area of research in software engineering field, where you have one set of concepts, another set of concept, and you want to transfer them. For example, I have you can say two different input variables collected from a data set, and when I collect it from different data set, the number of inputs variable change. So I should be able to transfer the knowledge learned from the first model to the second model. I should be able to transfer. So this is an emerging area of research. Another emerging area of research is imbalanced data. We have discussed imbalanced data learning techniques. So in imbalanced data learning problem, what happens is that one outcome class is in minority and another is in majority. So you can apply various concepts for this. For example, oversampling, undersampling. Oversampling, undersampling means when you try to oversampling is applied when you try to you can say extrapolate the training points that are in minority. So if no class is only has occurred only 10 times, you trying to you know ex you know maybe repeat those things and try to balance the data by increasing the samples in minority. Undersampling means you decrease the samples in majority. So that basically comes with loss of information, because if you have 80 data points in yes category and you try to minimize it to 40 or 50, so you are obviously going to have loss of information. There is cost sensitive learning that you can explore. So all these are upcoming areas. Then we have deep learning, application of deep learning area in software engineering research, but data size is very small, so you need big data samples for application of to analyze the applicability of deep learning techniques. Then another area of research in empirical software engineering is application of hybridized techniques. Hybridized technique means when we use for example, I have a genetic algorithm, neural network, GANN. So what I have done, I have combined two techniques, advantages of two techniques into one. So that means I have hybridized them. I have used genetic algorithm for feature selection and neural network for validation, and I've combined the two into a single technique. I can use, for example, I use PSO neural network, PSO linear discriminant analysis, particle swarm optimization. So what do? I hybridize them. I combine them into a technique. So that is another area of research. Then also we can predict the just-in-time defect prediction is another area of where you can apply various things. So these are various areas where you can work on. So this was all that I wanted to tell. Any questions you have, you can ask me now.
Yes, ma'am. Good morning, ma'am.
Good morning.
Ma'am, actually, I am working in fault prediction area, and I have one question about the selection of machine learning techniques.
Mm-hmm.
From the paper, Lessman 2000 paper I have cited, he has categorized machine learning techniques into various classes. Like
Yes,
statistical
Lesman I think was
classifier.
published in IEEE transaction on software engineering in 2008.
Yeah, ma'am.
And he has done a very extensive research where he has used NASA data sets, and he has used various categories of machine learning techniques, and a lot
Yes.
many, I think 27 algorithms have been evaluated.
Yes, ma'am.
What is your question?
So, ma'am, my question is that first of all, I have applied feature selection technique and feature subset selection technique in CK matrix suits, and I am using process matrices also with them. And then I want to apply machine learning techniques. From this reference, I am taking one technique from each category. Is it the correct way to take the machine learning
Each category
technique?
means one technique from each category means
Like one technique from statistical classifier, like I am taking
that is
logic.
fine. But are you taking the same data that Lesman has taken?
No, ma'am.
So how you are selecting one technique from each category? How do you know it's the best one?
Yeah, ma'am. That's why I'm asking ki it's a proper approach to select the machine learning approach or not.
I don't no, I don't agree to this, because you need to see if you are taking the same data as Lesman had taken, then you can say the techniques that were found to be that were found to be best by Lesman, and you are using the same technique, same data set, and you are applying maybe different set of measures and metrics, then you can say that you already have established research and you are following it. Otherwise,
Okay.
how you are selecting only one technique from each category is questionable. The reviewer will ask you that how did you go about the selection of the technique.
Yes, ma'am. So what criteria should I follow, ma'am?
It depends upon your data set. What data set you, for example, if the data set
I'm using, ma'am, Promise repository data.
Promise repository data.
Ant Camel, JD
So you should
projects.
apply more number of techniques that are some well established by Lesman if you are following Lesman. Not one, multiple techniques from each category.
Okay, multiple techniques I have to apply. Okay. Then, ma'am, I want to design assembles using majority voting. So what should be criteria, ma'am? Basically in literature I'm studying that the classifier which giving less performance, you can combine them and design assembles
The classifier which, just come again.
which giving less accuracy, or which are not good predicting good results. You can combine them while you are designing assembles. So it is better, ma'am, while I am choosing different machine learning techniques, and from them I can like I'm taking example. For example, I'm using accuracy. If we are getting some
Accuracy is not a good measure. It has been proved in software engineering research. We never used accuracy. The reason is, for example, I'll give you an example. For example, I have a data set. It has 80 non-faulty classes, right? And 20
Yes, ma'am.
faulty classes. And
Yes, ma'am.
accuracy is 80.
Yeah,
Or
ma'am.
okay.
100,
That means
it's
all the
80%.
non-faulty were, all the classes were predicted as non-faulty by the model. But the accuracy will be 80% in that case.
Yes, ma'am.
So you should go for area under the curve measure.
Okay, ma'am. If I will take ROC, then from different machine learning techniques like random forest or SVM, I am getting, for example, one I am taking 80% or 79% or 60%. Then I should take, for example, design for 60 and 70.
60 and 70 means validation ratio.
Yeah, ma'am.
You want to go for holdout validation?
No, ma'am. For assemble design, I want to go for techniques, machine learning techniques. Which techniques should we have to combine?
So what is your question?
मैम मैं ये पूछना चाह रही हूँ कि जैसे मेरे पास मशीन लर्निंग की डिफरेंट टेक्निक्स हैं, फिर हमने उससे जैसे आरओसी की वैल्यूज निकाल ली, लाइक मैंने एसवीएम रैंडम फॉरेस्ट डिसीजन ट्री से मैंने आरओसी की वैल्यूज निकाल ली अपनी,
जी 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 जी।
फिर असेंबल डिजाइन में लिटरेचर में मैंने ये पढ़ा कि जिनकी आपकी वैल्यूज लेस रिजल्ट्स गुड नहीं है, उनको आप कंबाइन करके असेंबल डिजाइन करिए ताकि वो आपको बेटर रिजल्ट्स दे सकें।
ठीक है।
तो मैम उसके लिए हमें फिर मतलब कि मिनिमम कितने हम टेक्निक्स को कंबाइन कर सकते हैं एक असेंबल डिजाइन करने के लिए मशीन लर्निंग की?
I don't know. See, you are talking about assemble of what? एक तो there are assemble learning techniques, random forest, bagging, boosting. Already there are established assemble techniques. Okay, then and another technique is ensemble of various machine learning techniques. That is a different thing. What do you do is basically you apply, so for example, 10 techniques to the same data, and then you use majority voting and say that because eight algorithms are saying it will be yes, so you predicted yes.
Okay.
So I think you understood it, misunderstood what you are doing.
Okay. Actually, ma'am, I want to using majority voting techniques in machine learning algorithms.
So that we can design assembles. Is a different technique. That means you apply various types of machine learners, and then you use majority voting and say which is performing best. And another is ensemble learning, that you have, for example, random forest. Random forest create multiple trees.
Yes, ma'am. It's a assemble method.
Yes, that uses majority learning, and then it's in itself it's an ensemble learner.
Okay.
So before you go for a new ensemble learner, you need to analyze the existing ones first. Bagging, boosting, random forest, they are very good ones.
Yes,
and they are the best for promised data. They work very well when you use promised data collected from promised data repositories.
Okay, ma'am. Thank you, ma'am.
Any other question? Yeah, you want to ask something else, Pooja?
No, ma'am. Thank you.
Ma'am, please give your mail ID.
Ma'am, I have a little bit more curious. So you can share your mail ID.
Yeah, sure. I'm just typing it down.
Yeah, hello, ma'am.
Yes.
Yeah, ma'am, I have one
Yes,
query
Aman.
regarding hypothesis testing.
Mm-hmm.
Actually, when we are using a regression problem and all,
Mm-hmm.
I'm usually confused in the terms like what will be the role of hypothesis testing in regression kind of problem. I don't actually use while I solve problems. So, but usually I
In
see the
regression
people are.
kind of problems, what will be the role of hypothesis testing? You are
Yeah,
asking me
yeah,
that.
yeah. Could you please give me an example, like what will be the
Yes, I
hypothesis?
can give you an example. See, hypothesis
How
testing can be,
prediction
yes,
problem?
yes, just it can be used in two ways. I'm talking about empirical software engineering. Should I remain talk about the concept of empirical software engineering, or general you want to know?
No, I would like to know what would be the example if I have a house price prediction regression problem.
Okay, okay.
Then
Just
what
if
would
you
be
have,
the
for
hypothesis?
example, yes, let's talk about if I want to predict lines of code of a software. So the outcome variable is, absolute in this case, right? Number of lines of source code, that is the outcome. I want to, have in maintenance phase, I want to see how many lines I've added, deleted, and been changed. Okay, it's a regression problem. So there are two kind of hypotheses I can make. First is one-to-one hypothesis. That means one-to-one means when I say that coupling is related to the number of lines changed or added or deleted in the maintenance phase. So that is a univariate hypothesis I can make. For example, let's take weather prediction problem. And when I say, but in weather prediction, the outcome is nominal. But if it's okay, even if it's it's the same as we do in you can say classification problem. So I can have univariate hypothesis means I can find individual. I can state the hypothesis that states individual effect of each and every measure on the outcome variable. For example, if coupling increases, the number of lines of code that are changed in the maintenance phase will be high. That can be my hypothesis. Another hypothesis I can make is if I have two machine learners that are, for example, linear regression and neural network, both can work in with the regression techniques. So I say that neural network is better than logistic regression. That is another hypothesis. And I want to test this hypothesis whether it is better than logistic regression or not. So there are two ways of forming hypothesis. One is on the concept and another is on the machine learning technique. Am I clear, or you want to ask something?
Yes,
Else?
yeah. Yeah.
So anyone else who
Thank you
wants
very
to ask something? Yeah, thank you. Any other question?
Any other query? Ma'am, thank you so much. It was excellent session. So far, the best of the session that we have attended in this STC. We really enjoyed a lot. And I'm the way students are asking query, I feel that they have also enjoyed the session thoroughly. Thank you so much, ma'am.
Thank you so
for
much.
the.
Thank you. So I have already put my email ID here. So anyone who wants to ask something, he or she can, mail me or contact me.
Sure, ma'am.
Okay, then thank you so much. Should I leave?
Yes, ma'am. Yes, ma'am. Ma'am, I have sent you an email. Kindly fill that form and reply that to me.
Sure. Thank you so much for inviting me. Thank you, all of you.
Thank you. Yes, I also feel that this is the best session of this STC. I also have thoroughly enjoyed. So we'll be meeting in the afternoon session. The session will be by Miss Niharika. She'll be telling us some tool for agile methodology. So we'll be working on that tool. She'll be giving that session. So we'll be meeting at 3 o'clock in the afternoon. Thank you, everyone.
Thank you.
Thank you, ma'am.
Please leave. Beta, please leave. The meeting is over.
A very good afternoon to all the participants. So in this afternoon session, I would like to welcome Dr. Niharika Garg. A brief introduction, Dr. Niharika Garg, she has received her PhD in computer science from Manasthali Vidyapeeth in 2018. She worked for 12 years as an assistant professor in computer science in several universities. Later, she served as quality consultant in United Health Group, USA, for more than 2 years. She is currently working as a Scrum Master since last 2 years in Optum Global Solutions, Gurugram. During her tenure in academics, she completed successfully the research project sanctioned by Government of India under DST Women Scientist Scheme. She has several publications to her credit in various leading international and national journals. She has also published chapters in various books. So it's an honor to have you with us, Dr. Niharika Garg. I, on behalf of the organizing committee of this STC and Department of Computer Science, NIT Jalandhar, welcomes you. Over to you, Dr. Niharika.
Thank you, Jagdeep. Let me turn on my camera. Let me know once you can see
Yes,
me.
you are visible, Dr. Niharika. Your camera.
And okay, thanks. So hello everyone, and hope everyone is safe and enjoying their days during this tough time. So and thanks, Dr. Jagdeep, for the nice words about me. I think you have briefed already much about my background, that I had a very diverse experience in teaching and in company also. So I served around 12 years, and after that, with that knowledge, when I transitioned to Dr. Jagdeep, there is a request for you. Can you mute yourself?
No, I'm sorry.
Yeah, thank you so much. Yeah. And I would request everyone that they can keep their phones on mute. And obviously, I'll give you the options to ask for the questions. So yeah, so that was a very diverse experience for me. And when I started journey with the industry from after 12 years of experience, I was not sure that I will fit into the software models or not. But yeah, the basics, the studies we do during our academic times, say, so they pay a lot. So I'm not sure about the background of the audience here. So I'm hoping everyone is very well aware of the software concepts and the project managements and all. So hoping that you have gone through those concepts through your graduation and probably through your current post graduation syllabus or not. So on this, let me share my screen. All right, hope everyone can see my screen.
Yes, it is visible, ma'am.
Oh, thank you so much. All right. So before I start with the agile methodologies, the topic of this session, and I'll be talking about the Scrum methods, what are the different Scrum methodologies, and what are the various tools we use in that. Like one of the major tool which is mostly used in most of the organizations nowadays is Rally, earlier used to known as CA Agile. So before we go on, anybody has any idea on what is Scrum and what is Rally, or what is the need of software lifecycle models? Why we need those? If you think of, I know you all must have seen, must all have read about what is software lifecycle model, but why we need those? Can't we just execute the projects? We do the requirements, we do the executions, testing, just like that. Why we need a software lifecycle model? I would like to hear from anyone from the audience, please. Just trying to set a ground so that, I also know that where you guys stand and what I'm trying to cover here, and we all are in sync here. Anyone, even if there are faculties, I would love to hear from faculties. Please, anyone. I cannot see now the participants list because I'm sharing. So please don't hesitate. And anyone, please, what do you think that why we need a software lifecycle model? No one wants to talk?
Okay. Yeah, actually, we may want to have a high quality software through which we can satisfy the expectation of customer.
Okay. So when you say the expectation of the customer, what do you say or understand by who is the customer?
So whosoever is using, I want to say from the very beginning to the maintenance, and this cycle goes and goes. Means
Okay.
that's why.
Okay, yeah. So that's perfectly fine that you are saying that the customer is the one who is using the software. That's totally fine. Anything else that why we need a software lifecycle model? I'm sure you guys have heard about the waterfall models and iterative waterfall model, prototype, and spiral. There are so many models for the software life cycles. So why those are defined and what is the need of those? Do we really follow those while executing the projects in industry, or are they just the theoretical concepts? See, I'm trying to share my experiences because I have been to academics and then I have been to industry. So I have seen what we study and what is being taught into academics and how much it is followed. So if you guys will share your thoughts, so it will be very easy for me, to go ahead. We are together for almost 2 hours, so if you guys can answer and like make it interactive, so it will be interesting. I know this is post lunch session, so I don't want anyone to sleep, so let's make it interactive and share your thoughts.
Ma'am, we need this model so that the things will go in a well organized way. For example,
Exactly.
first we have to check about what are the requirements, that what are the basic requirements which we are going to be needing to in order to make any project work.
Okay.
Then some
Ma'am.
coding part will be done.
Actually,
Yeah,
ma'am, we may
accordingly.
have variety of projects. Some projects need to build prototype because customer don't know anything about the project. So we have to give them some sort of prototype, and then we take feedback and redevelop the project. And there are some projects, so those are well defined and all. So to have a end-to-end better customer satisfaction, we try to have a different sort of steps through which we go through.
Yeah, absolutely fine. Absolutely, that was I was looking for, that how much you are from the understanding perspective. So yeah, this is obviously the software lifecycle models are required to give a structured way for our project management, like how we
Yes,
want
ma'am,
to.
helps in the
Yeah,
hello.
please go. Yeah, please go ahead.
Basically, it helps in a process development, now,
Yeah.
like user experience and policies.
Yeah, totally. So there are so many things when you talk of the software lifecycle model. It's just not developing a software. It's about the policies. That's what you were saying. Completing the documentations, understanding the requirements from the business. So it's not just developing a piece, but there are so many activities around that. So to give the structural way to those activities, so this concept of software lifecycle models is introduced. So before I go further, I'll talk about in today's session about the traditional project management methodologies we have. Like you have the waterfall method and spiral method. I can't recall all the names, but like waterfall, I think that was the base foundational traditional method, which was the origin of any software lifecycle model. And on top of that, after those changes were introduced and we had the new models like iterative waterfall version and prototype or spiral, then I'll be covering that what exactly is the agile methodology. So as I said earlier, nowadays most of the organizations are going on agile model. So what exactly is agile? So I want to see that how you guys understand and what is the difference between the traditional and agile, and what are those extra features or the advantages over traditional that everyone is just moving to agile world. Then I'll just give a glimpse of comparing both the models, what we have in waterfall and what we don't have in agile, the different agile frameworks we have. So agile is a methodology, it's not a tool. So when you say that waterfall model is not a tool, it's a method. To implement that method, we have several frameworks available in market. I am associated with United Health Group, that is now that is known as Optum. It's IT division. So so we follow Scrum. So Scrum is one of the framework for Agile. So it's, you can say it's a tool or it's a framework for implementing the Agile methods. Then the tool which actually we are using to implement the Scrum framework is Rally. Earlier it used to be known by the name of CA Agile. So this is now the new name of it, Rally. And I'll give you the tour of this tool, how we access that, how the different phases of a software lifecycle model, like in requirements or execution and testing. So all those, how we use this Rally tool to show the tracking or the progress during our entire software lifecycle process. And then at the end, I'll if I'll be left with some time, I would like to give you the vision which is coming as a future tool from the business perspective. So when we talk of the customer, so I'm talking of the business here, the customer. Now think of that, if customer requirements are also going into agile. So there is another tool that's called as AHA tool, which is converting the requirements of the customer or the business into an agile. So that will be a very short review on this. So these will be the overall objectives of my session. So let's start with our traditional, the foundational project management model, which is waterfall. I think I'm pretty sure that you all have seen this basic flow diagram and the different phases which are followed into this waterfall model. Anybody like to take the lead and talk about these phases? What are those and how they are executed? That what actually is implemented in requirements specification, or what is done in design, implementation, verification, maintenance, like what are these phases actually doing? Anybody wants to take a lead? Okay, no one. All right, so when we start with the first requirement specification, okay, from where the requirements are coming and where it is going. See, I'm again saying I'm making it totally interactive. I have not captured any text in my slides, so there is nothing to write here. You just listen and participate with me, and you will learn a lot about this project management. So you'll not find any text. So please come up that what is requirement specification, what we are doing, from where the requirements are coming up. See, we are trying to build a model. We are trying to build a project. Think of a website. We are trying to build a website, any shopping website. So what we are doing in the requirement specification? Anyone?
Actually, we are asking the end user or the customer that what are their expectations. Sometimes we give them some sort of form to fill up, and sometimes we had a talk with them. And
So expectations means like what kind of, can you just.
what functionality they want, and
Okay.
what is their objective. Sometimes they want a software which will work online, but there are some projects they feel that no, it must be distributed, or there may be variety of requirements that customer may have. Suppose you are saying for a website, and there may be the content or the functionality actually.
Okay. So when
Like
when
a description of a software system, na?
yeah,
Like
yeah.
what is to be developed.
Yeah. So when you say that the description of the project
Yes,
or what
ma'am.
is the expectation of the customer, do you think that the customer or the business gives the priority of the language also, that they want the code into this, suppose Java, or they want this language to be used Python, or do they specify these kind of things also when they give the requirements? Do you think that?
No, I don't think so.
Okay. Anyone else? Yeah, so this is one of the drawback we have for the waterfall. The traditional methodologies, why we don't have these kind of preferences from the business. When you say customer, I'm using business and customer. So for me, both of my terms are similar. Okay. So when you say that no, these kind of preferences are never given by the customer, like what should be the language. So what they generally provide. So if we are talking of a website, like a shopping website, what they provide, that how my website looks like, what are the different features in that, and what are the products you want to cover, like categories and all. These kind of things, or like those things, but they never define that what are the preference languages they want to go with. So this is totally by the design teams or the implementation teams. So here in the waterfall model, what happens is when a customer is given, as you said, a kind of form or a survey, that's different ways of capturing the requirements, like through meetings or through surveys or whatever it is. So they fill those, and from the basis of those documents, you gather and you analyze those into a software requirement specification document. So that is the document which is served as one of the requirement documents for your project team. So the requirements are converted by understanding and given to the next phase, that is the design phase. So if you'll see, all these phases are the sequential phases. So once one phase is completed, it goes to the another one. Like the output of first phase is provided as a input to the second phase. But so the design team has already submitted now, already got this SRS document, that is the software requirement specification document from the customer. Now they will work and they will design, they will give a high level design from the architectural perspective, that how what can be the different databases, or what can be the different programming languages should be picked up for the implementation of this piece of requirement. So all those technical decisions are taken in the design phase, not in the requirements specification. And whatever the decisions are taken in the design phase, that what is the language and all, there is no interference by the customer here. So they are just only interested in the end product, that they have given the requirement and they have given the timeline, and they have funded the amount, that this will be the budget of the project, and they will expect the whole end product. So that they are just expecting. Between that, there is nothing where they are playing any role. So that was the major drawback here. If you'll see, after design, the implementation teams come up, that which involves like coding. There will be a team of developers which will be working on the design, which was which was shared by the design team. And once the coding is done, only then the testing team is coming up into the picture. So there is no role of the testing team before the coding is done. They are not even involved in the design. So do you guys really think that this is a best approach, that the testing team is not even know that how the design, what are the different like databases? So when it comes to them for the testing, only then they came to know that okay, this is the code on this design on this databases, this is based. So their role just comes up there. Before that, they are not even aware of what is going into their world, into the customer world, from the requirement perspective, from the coding perspective. So that was another, again, a drawback. So, and when you are doing the testing, like you have already completing all the coding part. So, and if anything comes up, any errors come up, so all these phases go back again to the design team, that there was a flaw there, and then they will work on that. Implementation will be done again, then verification will be again done, and then end of the day you have the delays in your project deliveries. So those were the major challenges which project teams were seeing in the waterfall model, like whether it's a sequential, there is no interference with the customer, always delays. And this waterfall model technique is a very good model, but I can say that this is more appropriate where the projects are very small and the requirements are not changing. When you say that requirements are changing, then how this model will fit? Suppose the customer has given some requirements, x requirements on day one, and the product team has already verified the code and they are almost at the verge of testing. Then they suddenly come to know that, oh, there is a change in the requirement, and the business is giving some X2 requirements. So what is the point of doing all these exercises? So waterfall model does not have any provision to go back. So that was the again challenge with the waterfall models. So there are plenty of projects. So again depends on the project requirements, the size of the project, that which methodology it should fit in. If there are very if it's the requirement is very small, then just people just do the requirement quickly and just design and implementation and testing when they know that there is no change in the requirement. So this is the best model in the implementation. Even in our world, we sometimes follow waterfall too. So I will not say that we are 100% agile, but yeah, we are trying to be mature, as much mature we can for agile. But yeah, somewhere, sometimes we do follow waterfall steps also. So moving to agile, when you have seen that there are so many challenges in the waterfall model. Now, if you see, this is a very high level cycle which is depicting an agile methodology, and there are many terms here which I'm sure will be very new to you, but I'll be covering all these terms in the session. So let's start with product backlog. So if you'll see there, in the initial two blocks, product backlog and sprint backlog, there is what kind of relation between these two? There is not a unidirectional arrow here. So it's not, there is no direction here. It's like a two-way communication. Sprint backlog, the things are going back from sprint backlog to product backlog, from product backlog to sprint backlog. Things are going back and forth. Then from sprint backlog, it is going into an iterative cycle. Now, if you see, I'm not sure, but I think this may be a little similar to your spiral model. Please correct me if I'm wrong. I can't recall what exactly was spiral, but it's a kind of loop, or I can say iteration, where if you'll see all the phases which we just saw in the waterfall: planning, designing, the development, testing, and release. These are all going in cycle. So it's an iterative process. Now, this is just one part of the waterfall. If you see, it's like cycle. And what is sprint here? Sprint is the smallest iteration, I would say. It's an iteration. If iteration is one cycle, so the smallest cycle of time which is followed in Agile is called as sprint. Now, sprint, if I define in English, um, it's the smallest time where a certain set of tasks are completed by a team. So generally, it spans from 2 to 4 weeks. It depends on company to companies, but the standard practice is to follow a sprint of 2 weeks. So, and I also follow a sprint of 2 weeks in our organization. So, what is happening around these? So, if you'll see, this is a 2 week cycle. Along that 2 week cycle, everything is planning, everything is designing, development, and release. So, can you imagine that how in 2 weeks, how all these activities can be done? When you were just before that, you were seeing the waterfall model where you were developing a whole program, whole project, just following these 4 steps. So don't you think that there is a kind of contradiction that how we can achieve anything, a final product in just 2 weeks of cycle? So it's not only a 2 week cycle, it's the multiple iterations. So but what basically we are doing in Agile is we are breaking down the product which is required into small pieces. We are breaking down the requirements, and the teams work on the requirements, the small requirements in iterations. So when I say that we are breaking down the requirements into small pieces, so that is called as product backlog. So if you see here in the first step, I'm showing a product backlog. So this is representing the product requirements, that the requirement of a product like X1, X2, X3, X4, X5, X6. So these pieces are broken down requirements and they compose a backlog. So once these requirements are broken down into pieces, and these requirements obviously as usual is coming from business or the customer. So they have broken down the requirements that okay, my whole product should be divided into these pieces. And here in Agile, the business, the customer is not standalone. He's working with the whole development team. So that's the biggest difference between waterfall and Agile, that it's not only the customer, but the team from the development is also helping the product owner or the customer to maintain this backlog, to to break down the requirements. So see, customer is not the one who can break down the requirements, because they just know that okay, I need a website, but they don't know how to break those into smaller pieces. So they need technical expertise there. So that's how here the role of the Agile team comes here, that all these activities are in coordination with everyone. Customer is from the beginning to the end of this whole diagram. I will show you in the later diagrams. So once the requirements are broken down into pieces, then few of the requirements come to the teams. It's not like that all of the requirements will be given to the development team. No. If here out of 6, like 1 or 2 requirements will be part of the sprint, that is the iteration, that is for the 2 week cycle. Like this 2 week is coming up, like if I say from Monday my 2 week cycle is gonna start, so then I'll be giving some of the requirements which is obviously feasible by the team to execute in this sprint. So that becomes the part of the sprint backlog. And then it goes for that 2 week cycle of developing and testing and release, and then the product is released. So it's a very high level. I'll come back to you on this with the more details. Any questions till now? Anyone? Any questions? Okay. Okay, let's talk about some scenarios. Now, I'll be on mute now, and I would love to hear from you guys. I have just explained you that a very high level, that what is the difference between waterfall and agile methodology. So I have given 4 examples here. Taking the restaurant orders or execution of the restaurant orders, remodeling a kitchen, Google search tool, car manufacturing unit. So what do you guys think? Let's talk about first restaurant orders. What do you guys think, that is it based on waterfall or is it on agile? Anyone, please?
Restaurant order is more of a cyclic process. Agile.
Okay. So when you okay, I just want to hear either agile or waterfall.
Restaurant agile,
Mm-hmm.
car manufacturing waterfall,
Okay.
um, remodeling a kitchen waterfall, and Google search tool. If we are talking about building it,
Mm-hmm.
uh,
Yeah, building it.
uh, it can be done either way. But if we are talking about building and maintaining, then agile.
Okay, then let me ask some questions. Okay, restaurant, you are pretty close, uh, some here and there. So for the restaurant orders, why you guys think that it is, what do you say, agile? Okay, why it is agile?
Ma'am, if we are building a restaurant order system,
Mm-hmm.
there will be a lot of changes if a new dish comes up. If there's a significant amount of change happening again and again, so
Mm-hmm.
consequently, we'll need to modify our application rapidly.
Yeah. And anything other specific when we are giving the orders, you are going to a restaurant. Have you ever experienced that your table is not served and someone else is getting their order prior to you? Have you ever encountered this kind of scenario ever?
Yeah, ma'am, it happens.
Yeah, it happens, right? So what is happening? Like we are seeing that sometimes the priority is given to some other order before us because we are thinking that we are sitting from a long time and we are not given. So that is giving the priority. So it's the restaurant team who is deciding that to which table they are giving the priority. And sometimes I'm sure you guys have seen that if you have ordered 10 items, like you have ordered from the snacks, from the main course, from the
Yes, ma'am.
dessert.
Big order takes more time.
Yeah, and it's not always that you are getting dessert at the same time at the time of snacks. You also say that break down the requirements, right? First bring the snacks, then bring the main course, and then bring the dessert, like that, right?
Yes, ma'am.
So,
Sometimes we even specify that bring the material as it is prepared.
yeah,
Don't wait for everything to be prepared.
absolutely. So you are the customer there. Now think from the customer perspective, what you guys are doing. You are giving the requirements, and sometimes you guys change your requirement also. By sitting, sometimes you say that okay, if you just change your mind and want to eat something, and you just check with their team that if they have not processed their order, please change my requirement. Some kind of these scenarios always happen when you are sitting at restaurant. Correct me if
Yes,
I'm
ma'am.
wrong, right?
You're
So
right.
what is this? This is all agile. So you are being given the priority. The customer is, who is bringing the value to this business. Restaurant business is only driven by the customer. So that's the only value which is being generated to this business, and they are giving the priority to the customer according to their orders. And if the customer wants to change the order, so they accept the changes also. But those things were not possible in waterfall. If there are many restaurants, I will not say that, who are as generous, but some restaurants, they have a very good hospitality, that they say, okay, if you want to change the order, that's totally fine. So they are accepting the customer's requirement, and accordingly they are processing the new order. So that is what happening in the agile world, that if the customer has given a requirement, and someday later the customer realize that okay, now there is a change in the marketplace, then uh, that change is totally welcomed by the product team. So That's the beauty of agile we have, which was not present in waterfall. So I hope I'm making sense here.
Yes, ma'am.
Okay, now talking of car manufacturing unit. So these different scenarios, I will not say are talking of all the features of agile, but they are all differentiating in some way. Let's talk about car manufacturing unit. When you say car manufacturing unit, what is that? There is an industry which is producing some cars, right? So a design is given by the customer, and at the end of the development cycle or the production unit, you get a full-fledged and luxurious car. Before that, customer can never see how car looks like, and even it cannot go to the customers because you cannot deliver a non-working car to your customers. Am I right here? Like if the requirement is given to deliver a working car, you cannot deliver in between. Until unless the whole car is developed, you cannot deliver anything to your customer. So what is happening here? Like it the requirement cannot be broken down here. If they are saying they need a car, then you need a working car. You cannot deliver in between. So that is totally a waterfall. In waterfall, we cannot do the intermediate deliveries, but in the agile, we have multiple deliveries in between because we are breaking down the requirements. That is how the concept of sprint comes in, the iteration comes in. One iteration, one sprint, and you have one delivery. Another sprint, another delivery. That is not possible in waterfall. So car manufacturing unit is totally a waterfall model where end product is just a working car. You cannot deliver non-working car to your customer. So this is your waterfall. Then let's talk about remodeling a kitchen. Now remodeling a kitchen is remodeling. It's not developing a kitchen. So think from that perspective, we are remodeling. So it can be either agile or it can be a waterfall. Think from that perspective that you are renovating your kitchen with some of the part. So you are asking your contractor, just do on this first and then deliver me this part. Then work on later and then deliver that. So what you are doing, you are expecting the delivery in phases. You are asking that just work on these 2 days and deliver me the drawers, and then you can work on the remaining parts. So that way the delivery is continuously coming to the customer. So that comes the concept of continuous delivery. So this again can be agile, but another thing is it depends again on the customer. Suppose the customer wants, no, I want the whole kitchen at the end only. I don't want any intermediate results. So that will then fall into the waterfall. So this can fit into both waterfall and agile. And finally, the Google search tool. Obviously, Google search tool, when we talk of generating a tool, so itself, when we say of the search tool, the requirement gatherings. Do you think that at the very beginning, we will be very well know that what are the requirements of this tool? I don't think so. We can define the requirements in the very beginning. So the requirements are always evolving in the Google search tool. If you'll see, we always receive so many updates for all the applications. What are those? So those are deliveries. I'm sure you guys must be receiving a lot of updates on your phones. So what are those? Those are different iteration deliveries. Like one day they realize that this should be the part of my software application. Then they are delivering, and then again next day they are finding another requirement. Then they are working, and then they are in the next iteration they are releasing another part of that to the customer. So that's a continuous delivery. So continuous delivery, continuous integrations, and breaking down the requirements. So all these scenarios fit for only agile, which are not possible in waterfall. So I think I have made some sense here. I will give you guys now a chance to talk about the differences which you are seeing in the picture. What you are seeing here in the waterfall and what you are seeing here in the agile, and what is the difference which you can inference from here. Please, anyone.
So, ma'am, waterfall is basically making all thing in one big chunk and delivering it. And agile is a strategy using multiple iterations or multiple smaller segments one at a time, and then completing the segment and moving on to the next one.
Exactly. So if you'll see the challenge which we are seeing in waterfall, the requirements become so big that they are very difficult to deliver it because the project has become so big. And in the case of agile, we are getting everything delivered in the pieces of sprints or iterations. So that's the beauty of agile. Let's come to the next one. Yes, anyone?
Yes, ma'am. Waterfall lacks the flexibility part and also the ability to modify the project once we are in a next phase. As back waterfall does not allows us to go back to a previous phase. So if one phase is completed, the project is stuck with that phase. If you are going to stay within the software development lifecycle.
Absolutely. Anyone else want to share their thoughts? I'm just hearing. I don't know the names and I cannot see the pictures. I'm just hearing. I think one voice. Can anybody please else want to share their thoughts?
Ma'am, I have one question.
Uh huh.
How this agile methodology is different than that of the iterative enhancement model?
Can you define the iterative enhancement model?
So, in the iterative enhancement model, we also delivering the product in multiple releases, just like we are prioritizing our requirement. And one set of requirements are implemented, then we are moving toward the another set of requirement. Then there will be release 2, release 3, and so on. So I
Okay.
just want to ask how the agile in that case it would be different than that of iterative enhancement.
Yeah, it you can say that agile can be an iterative enhancement, whatever the word you are saying. I am not familiar of that model, but yeah, it totally works on that way. Whatever you have defined, that you have broken down the requirements and then you are releasing it, and then you are working on the next requirement, then you are releasing it. So that's exactly agile is.
Okay,
That's
fine, ma'am.
yeah. So think of okay, I'll give you another example. Think of a piece of cake. I'm sure you must have all seen the cake, a piece of cake. Uh, think that it's a very big piece. And if you slice that in vertical pieces, getting that? There is a cake piece and you are slicing that in a vertical position. So what we are doing, the layers are all same. But what you are doing, you are dividing it, slicing it vertically. So what we are doing, we are breaking down the requirements. End of the day, the whole is the cake, but we are breaking down the requirements. The layers are same, like at the bottom if it is creams or vanilla, or on the top it's chocolate or whatever it is. Then what we are doing, in every slice you will see the same flavor, but we are reducing the size, we are reducing the requirements. So the layers are the phases here, like starting from requirement, design, implementation, and testing. In every layer, you have all these, in every piece, you will have all these layers. So, what we have done, instead of doing all the design and analysis and coding and testing on the whole piece of cake, we have sliced it down and we are working on the smallest slices. That's what is agile, and that's what you have defined it. All right, moving on. Another differentiation of waterfall and agile. So if you'll see on the left side, see the comparison here. What is the failure rate and what is the success rate? As you can all see, that success rate is pretty much high in agile as compared to waterfall, right? So why this is like, why is the failure rate less than what we are seeing in waterfall, and why the success rate is higher than in waterfall? The only reason of its iterative nature. That's what you were saying. So the iterative nature is why it's leading to a very high success rate, because we are slicing down the requirements into small pieces. We are not working on the whole requirements together. So that makes a deliverable product at very early stages, right? Understanding that deliverable project, like deliverable piece, is uh, done at very early stages. So if you'll see the diagram on the right side, the value is generated, the total value is generated after all the phases are done, like refine, build, and release. So that increases the risk, right, with the time. But if we are breaking down the requirements, we have small iterations, and after every iteration we have a release. So that way we are reducing the risk, that at least in an iteration or at the end of an iteration, if we recognize that there is a change in the requirement, or they realize that it is not required from the customer, so they can easily go back, so the risk gets reduced. So that's why the failure rate is very less in agile, and that's why it is coming, it's bringing so much value to the organization that everyone wants to now move to agile. So this is that. Again, I have shown different iterations here, that how in a waterfall everything from the start to finish, it's just sequential: discover, plan, build, and review. But in the case of agile, we have smaller requirements, and we are working on this all those phases, but in iterations. So if you see that from the start there is an iteration break, and you are doing all the steps which you were doing in waterfall. Now this is interesting. Now try to understand this. So we are playing here with three factors: scope, schedule, and costs. These are the major three factors on which any project management team always plays. What is the scope of the project? What is the cost funded for that project? And what is the schedule or the timelines? These three are always the variable factors, the playing factors we have in any project management model. But how in waterfall and how in agile these factors play their role? So if I'm saying on the left side predictive, you can say, is the another name for waterfall, because predictive is when you know everything in advance. That's the meaning of predictive, right? That from the beginning you know that what is the requirement, there is no scope of change in that. So if you will compare these three factors for agile and waterfall, see the difference. This is called as triangle model, where on the left side, if you see, scope is on the top, which is a fixed factor. Scope is always fixed in waterfall. You cannot change the requirements. Whatever the requirements have been given from the customer to the team, it's always final. Once the SRS is final, until you deliver the project or until you are at the verge of the release, you cannot change the requirements. So that's how the scope is fixed in the predictive model, that is your waterfall. And schedule and cost are always variable. Why they are variable? Because when you are working on a requirement, sometimes you see a lot of test issues, or any development errors, or any delays from the resource issues, like suppose 5 people were working and due to some personal emergency resources went on their leave, so they couldn't complete the work, so that lapses the schedule. And then initially you thought that this will be the cost, but because of the multiple when multiple issues were found in the project, multiple testings involved, and then resources spended a lot of time on that increased the cost. So schedule and costs are always variable in predictive, in the waterfall model. Because why they are variable? Because they have to stick to scope. They have to deliver the scope whatever it is defined by the customer. But it's the inverted case. So we have an inverted triangle in the case of agile, where what is fixed? Schedule and costs. Scope is never fixed factor. That's why we always say in agile, we accept the change from the customer. Change is always welcome from the customer. So if they want to come up with a scope today and they want to change the scope of the project, we always welcome that. We never negotiate with them that, okay, no, we cannot work on this scope because you initially decided. That is not agile. If today they are giving us a scope and next day they are adding some scope, we totally accept that. That's why scope here is a variable factor. And to maintain and for that scope, obviously when that scope is changing, uh, uh, So schedule and cost are never changed in agile. So that's a fantastic thing for agile to to accommodate that scope. We always stick with that schedule. Suppose 6 months is the time given initially for a particular scope by the customer team. Now they are changing the scope. That doesn't mean that we will deliver whatever the additional scope they have done in that similar schedule and the same cost. No, it can never be done. Suppose they have asked me 10 requirements, now next day they are giving 20 requirements, they are changing their scope or adding their scope. That doesn't mean I will deliver the same thing in the same schedule and in the same costs. Then why they are in fixed factors? Because they are giving the priority. Initially they have given the 10 requirements, now they have given 10 more requirements. So what the team will do, they will ask the customer define the priority of that scope. They will not do that. They will accept the change, but along with that they will ask that what is the priority of these 20 requirements, new 20 requirements, which requirements are the top priority items for you. So they will not change any schedule for the delivery, but they will change the priorities, that what is the topmost priority which can fit into their schedule and which is again into the limits of the funded budgets. So that's how the teams work. Even the requirements change, but change doesn't mean that we are accepting the change. Welcome change, change is welcome, but we ask the priority. So that's the concept of prioritized requirements, which is a very important feature in agile. That how the requirements are prioritized to fit into the schedule and costs. So this is the major difference between agile and waterfall, and there is no concept of prioritizing the requirements in waterfall. Whatever the requirement items from 1 to 10 is given, so they execute all. So in agile, we prioritize, and if the schedule allows only 5 items to deliver, so we deliver only 5. So that is another difference. Okay, this is a very important concept of any agile methodology. I think I have covered most of these items in all the examples, but I'll give you a brief overview of that. This is called as Agile Manifesto. When the agile concepts came in, so the founders came up with these 4 values or 4 manifesto items. They value individuals and interactions over processes and tools. What does that mean? What are individuals? Individuals are people. Interactions are the collaborations among those people. See, in agile, people are the value driven. People are the one who are developing the software. See, you are the developer. You are generating the code, you are developing the product. Any software or any tool is not working on that, you are developing that software. So you as an individual or as a people are the top priority values in agile model. So whatever individual is, whatever people, whether the people who are generating the requirements, who are working on that requirements, are the top given the top priority over any process or any tool. Whatever the interactions, the collaborations, like the customer is saying something to the product team, so that interaction, that collaboration is given the most priority over any process and tools. Some companies always struggle on these processes and tools. I'm sure you guys must have seen in where, if you are studying also, or if you have any chance to work in an organization or in a company, that sometimes we follow, sometimes we use kind of tools which are not bringing any value to us, and we are following some processes which are not even bringing any value to us, but we are being told that we have to do this process, so we are just doing for the sake of doing that. So that is totally eradicated from agile. So they say don't do any process which is not generating any value, because the time of the individual is very important. So I'm talking from my experience that actually I have worked on a waterfall also and on agile. The way agile is saving the time of the individual, it is bringing quality on the board. So we have much more time as I used to have when I was just doing the ad hoc processes which are not even bringing any value to me, and they are just the part or just the directions from the organization that you have to follow this process just for the sake of that. So that's the first value which Agile brings up, that we value individuals and their collaborations over any processes and any tools. Don't follow any processes, don't use any tools which are not bringing any value. So that's the first value. Then working software, we believe in delivering the value to the customer, not over any comprehensive documentation. See, you guys are always doing a lot of documentation, either from the faculty perspective or from the students perspective, which are not bringing any value. Like if I say that you are performing an experiment and you are preparing a big manual on that, so it's just to do that, preparing a whole big bunch of documents which nobody is reading those, just not bringing any value on table. So rather than work on building a product, work on delivering a software rather than working on the documentation. Like if we talk from the project management, when the customer gives the requirement, we start building SRS, software requirement specification documents. What is the need of that? When customer is collaborated with the team from the very beginning to the end of the product, and they are there with their requirements, why we need to prepare a whole bunch of documents when they are always with us? They are always with us in every phases, whether it's requirement gathering, whether it's design or analysis or even developing or even testing. So there is 100% collaboration of the customer. Then why we need so much of documentation, building those documents from the design perspective, that this is high level design and this is the testing document. We don't need those documents. When everything is visible to everyone, then these documents are not preferred over a working software, though there are some compliance documents, audit documents which we have to do. So that is totally justified. See, the objective here is avoid those documents which are not bringing any value to anyone. So that's why the second value says that prefer working software over any comprehensive documentations. Then third is customer collaboration. Again, that's the same thing. So customer collaboration is that we are working totally from the beginning to the end with the customer, and we have full collaboration, whether it's the change in the requirements or their views or their preferences. So it's not a negotiation, but this negotiation, you can say it's a collaboration, that we are working together with the customer, and we are not negotiating on the requirements. Whatever they are giving us, offer, but not like as in waterfall, that they what they have given us will be the totally end product. Even if you think that that is not feasible from your team, but still you cannot say to the customer, because that's a customer. So you don't negotiate here, but you successfully collaborate with the customer. Then responding to change over following a plan is again accepting the requirements, if there is any change in the requirement from the customer, and then adapt it and welcome it and respond accordingly. Not instead of following a defined plan. Like if you have seen in the construction companies, you have a what do you call as a blueprint or engineering artifact kind of thing, that this is the diagram or this is the plot which should be executable at the end of the day. So there is no such plan. So the requirements are there, and if there is any change in the requirement or any priority changes, so that is totally welcomed by the agile team, and they don't stick to a following a strict plan here. So that's very important. The manifest and the whole agile concept is using all these four principles. I'll just quickly go through these aspects. So flexibility, we are flexible on the new requirements. Scope of the work can change depending upon the customer. Work breakdown, we are breaking the project into small cycles or into the small requirements, and each cycle is known as here sprint. right? Sprint is the smallest cycle, which is a deliverable cycle, and it's almost of 2 weeks generally, but it can be 2 to 4 weeks, but normally the standard practice is for with 2 weeks only. Value of teamwork. So the team members, they coordinate with each other, they work together, and they know each other's work. It's not that that design team is working, so the testing team does not know what the other team is working on. So they all work together and they share their responsibilities, whether it's a success rate or it's a failure rate. Everyone shares the responsibility of each other. So that's why the agile team is called as self organizing team. Then iterative improvements, the work is done in the cycles to make the final product better, because we are breaking down the requirements. So that's working in an iterative. And cooperation with the client is that customer is always collaborated and involved in all the stages of the software development, whether it's development or testing, so that anytime if there is any change in the requirement, that can be incorporated into the next iteration. So these are the aspects. Talking of the agile frameworks, the different frameworks we have. Okay. Okay. Let's think of the agile frameworks as an ice cream. Okay. Agile frameworks is like an ice cream, and you can have any flavor of that ice cream. But again, it will be called as an ice cream, whether you go for vanilla, if you go for butterscotch, or if you want to go for chocolate. What are these all? These all are flavors, but all these are called as different ice creams. So this is what agile frameworks is. Agile frameworks, we have different agile frameworks available in market, but all are based on agile manifesto, the one which we discussed just now. So uh, all these are what? Flavors. Scrum is a flavor which is based on agile. Another flavor is Kanban. So based on the requirements, every company follow different frameworks for the agile methodology. I have seen mostly Scrum and Kanban, but in today's session, I just want to cover only with the Scrum, because Scrum itself is a huge has huge process which a lot of ceremonies, names, the teams. So I think if you understand Scrum, you will be able to understand rest of those. So let's talk about Scrum. So again, now Scrum is okay. I'll take a pause here. And any questions till now? Before we jump to what is Scrum, and then I'll cover to the Scrum tool, which is Rally. Any questions, please? Anyone, if have? No questions? Is everyone awake?
Yes, ma'am, of course.
All right. So anyone want to talk about what is Scrum? I know that this is an agile method, but anyone, any idea on what Scrum is?
It is, from what I remember, I read about it once or twice. I
Mhm.
think it is a methodology in which we basically uh, uh, select a few requirements and work on them, and basically there's a feedback quotient involved where we rapidly share the progress with the customer or the user, and we use that feedback for designing the next sprint.
Okay. Yeah, wonderful. So absolutely, this is obviously Scrum is what this is agile. So it's one of the framework of the agile. So it has all those manifestos which we just talked about. So everything, whatever was the manifesto, whether sharing the feedback or it is iterative and incremental and breaking down the requirements. So everything is Scrum too. So whatever agile is, it's Scrum too. So, but yeah, it's one of the framework which has its own structures, so which we will talk about. So Scrum is again not a tool, but it's a framework. And for that implementation, we have other tools like for like extreme programming, which I was just showing you before, that these are just the flavors for the agile framework. So this is not the only framework for agile, but we have plenty of frameworks available in market. So agile Scrum is one of the agile framework. So other than that, like Crystal and XP programming, so these all are other flavors or other frameworks of agile. So I think we have already talked about the agile manifesto and the values. So again, the Scrum values and principles. So Scrum is totally based on these 5 values. So I'll just give you guys 1 minute to go through these values and see what you understand from that. We have covered everything in the previous slides. So it's talking everything what we just discussed in the form of manifesto or the values. So it's everything is same. Just go through this and see how much you can grasp from here. And please, any questions? Okay. Anyone, any questions on these values or anyone?
Ma'am, let me know. Excuse me, ma'am.
Yeah.
Ma'am, let me know how is an agile testing methodology like different from other methodology? Like, what is the different?
Agile, you are asking only for testing methodology?
Yes, ma'am. Testing methodology.
Okay. So there are different testing methodologies which are followed throughout the project models, project development process. So what do you understand about the other testing when you say that how it is different from other? What are the other testing methods you know about? Then I will compare that with what is present in Agile. When you say that how it is different from other testing methods, what are the testing methods you think of? How testing is performed? Do you have any perception in your mind that how testing is done?
No, ma'am.
Okay. So generally when we talk of the waterfall model, what is done? A piece of code is developed and then the whole piece is given to the testing team. They do the unit testing, they do the regression testing, they do the integration testing. But what is happening in Agile? You know, the Scrum team, the team which is working on the development, so that is totally responsible for either the development or the testing, everything, even the requirements analysis also. So what they are doing, the testers, the testing does not start once the code is developed by the code. See, I have played the role of a tester also in a Scrum team. So from the very first day, when
Yes,
this
ma'am.
iteration, when the very first day when the iteration starts, that is the sprint starts, I also start working on that requirement. How? I start writing my test cases based on the requirements given to me. I start generating that what can be the different possibilities, which can be the scenarios of my testing. So the developer and the testing work parallelly. It's not that once the code will be done, only then tester will be gonna check. So that's what you have developed a piece of code and I'm just checking that. I am not even seeing that what is the requirement. So here the difference is the test cases, the testing is the requirement basis. It's not from the code basis. So whatever the requirements you are seeing, you generate the test cases from there and you see whether the code is built based on that. So this is called as test data driven methodology in Agile. This is TDD. So it's like you are working on the test cases and then the code is generated based on that. Like, so it's like parallel work between the developer and the tester. You are working on your test cases and the coder is working on its code.
Okay, ma'am. Thank you.
Uh, and talking about these values, so I think you guys should be pretty clear of these. So courage, uh, I'm hoping that you guys are familiar now. At least you have some idea of what is Scrum team. Scrum team is Scrum, the team which is working on an iteration, multiple iterations also, but which is working on a piece of code or an iteration that is called as a Scrum team. So as a courage, when we say that courage, so they have the full authority and they work on the requirements they choose that what should be the right way of doing that. So they have total authority on how to develop that. Obviously they get the approvals, but they are the deciding factors, the Scrum team.
You mean
Then
these are the primary responsibilities of a
yeah,
Scrum team, no?
right, primary
Okay, nice.
responsibilities like analysis of the requirements, designing and coding and testing, everything is all done by the Scrum team. So Scrum team is the one which is totally responsible for delivering. Then focus is everyone is focused on a sprint is again a 2 week iteration. So whatever the goals were given to the team, the Scrum team in the sprint, so the goals should be the end result should be the that how those goals are achieved after that Scrum. So everyone's focus is on after 2 week cycle what has been delivered by the team. And then commitment, when a Scrum team has been given some kind of tasks, that these will be the tasks which will be your goal for this 2 week. So they commit for that, and then in that 2 week cycle there can be no change in that requirements. So that 2 week cycle is a very protective cycle. In that only the Scrum team has the full authority. They cannot accept any external requirements change. Whatever the goal has been given to them before the start of that sprint or the iteration, they have to commit to that. So I will show you how that commitment works. Then respect, everyone respects each other. They are independent people, they are self-organizing team. In a Scrum team you have developer, you have tester. If suppose tester is not available, so it's a responsibility of the other team member to cover up the task for that. It's not like that, okay, my tester is on leave today because of some family emergency, so we cannot test that and we cannot deliver that. This doesn't work like that. So if you have committed for that, so you are a self-organizing team and you have to respect each other's responsibilities. And in their absence, you can take their task too. So openness is again, because I told you guys earlier also that the stakeholders or the customers are always collaborated and involved from the very beginning till the end of each and every phase of the software lifecycle development model. So at any moment, any stage, if they see they are seeing any risks or any challenges they are seeing from the requirements perspective, or if they have any doubts, so they come to their customer, they ask them, so they clear immediately that way. So the role of the stakeholders is from the very beginning to the end of the release of the product. So that's how they are very open in all my meetings. Whenever whatever we are doing, my customer is always there with us. So it never feels that there is a break, and whatever we want to ask, we can ask them immediately. So that's a very good thing in Scrum, which was not available in Waterfall. So this is a framework. Okay, let me go to the next one, this one. Okay, now I will spend a few minutes on this and I'll expect questions from you guys. Before that, Dr. Jagdeep, how much time I have? Um, do I have 30 minutes with me?
Yes, Dr. Niharika, you can continue up to 5. It's up to you if you
Okay,
want to wind up early.
okay. I just need, I think 30 minutes should be fine.
Okay.
All right, thanks. So, okay, now see this, and you will see so many roles here. This is all Scrum. If you see here, you will see a lot of terms here. Just go through that, then I'll start explaining it. I'll just want to give you 1 minute on that to see this. If you have understood this, you have understood what is Scrum and how the teams work. It's a very beautiful illustration of the Scrum model. And
Ma'am, product backlogs is the requirements
yeah,
basically.
yeah, it's a requirement. See, you need to understand each and every term here. That's very, very important because these terms are the language which we use in our development world. We talk from the sprint planning perspective. We talk in the terms of tasks. We talk in the terms of sprint backlog. We talk in the terms of review, the features. Each and every word which is written here is, you can say, the language, the Scrum language. So please just go through this cycle and see how much you can grasp from here before I start explaining that. Anyone wants to try what is going on here? How this process is working? Anyone wants to try? I would really love to see that how much you guys have understood from here.
Ma'am, so basically, what I'm able to understand is initially we take input from end users, customers, teams, stakeholders, etc. And after a significant amount of product design, product requirements, and features are established, we move on to a team which selects how much work will we be focusing in the immediate next sprint. That will be priority driven, as you've already discussed that each task has also an associated priority with it. So we will choose the things which are most high priority or which are most core components without which other components cannot be built, and we will establish those tasks for a sprint backlog. After that, as the sprint duration is decided, assuming it's 2 weeks, we will not make any changes in those requirements in the 2 weeks when the sprint cycle is on. In each sprint cycle, we'll have a daily meeting with the Scrum team, and at the same time, product backlog requirement will also be refinement will also be going on for the sprint. So the tasks which have been selected for the sprint will also be prioritized among each other. And if there's any change due to the work inside this sprint by these team members, then that thing will reflect there. We will not be accepting any external changes, but if the internal Scrum team decides that there is slight change required in the tasks, then that will be accommodated by the product backlog refinement. After the sprint is almost over, we'll go to the review portion. What I haven't understood is the role of Scrum Master and retrospective. Rest, this is what I was able to infer.
Anyone else want to share their thoughts? Or if they have some different perception about this which you just shared? Anyone else? Any other idea? All right. So there were some deviations from what you explained, which are very important to understand. Like you said, that this list is prioritized. And which list is prioritized? We are talking of first thing. Then
Ma'am,
another thing.
product backlog.
Yeah. So product backlog is the one which is the prioritized list because that is coming from the customer. Another thing which you were little deviated, that if there is any change during the sprint, so the team needs to accommodate that. So that's the thing, that there is no change in the requirement during a sprint. If they have to do some extra tasks in that to accomplish a task, So it's their commitment. They have to complete that because they have committed before the start of the sprint. So when they pick the task, so they have to make sure that whatever they are picking, it needs a fully commitment of that 2 week cycle. So let me first start from the beginning. So when we say that the inputs from the end users, the customers, the teams, and other stakeholders, it can be anything. The requirements can be from anyone, stakeholders or end users or customers. What do you guys say? Product owner is the customer or the customer representative. Please try to understand each and every word. What is the role of product owner or scrum master? Because it would be easy to understand this whole cycle. So when we say that the requirements are coming from the customers or any stakeholders, so product owner is the one who is the intermediate, you can say, between the product team and the customers or the business. Either the product owner can be the itself customer or he can be the representative. So but he is the one who is passing the information from the end user to the product development team. So that is why it is called as product owner. So he is the owner of the product, who owns the product, because he is the representative of the requirement. He maintains a product backlog. Backlog means it's the list of the requirements. Now, it's the responsibility of the product owner to prioritize that. As I told earlier, that we work in a priority model. So it doesn't mean that today the requirements are 8 and tomorrow it will be 15, but we will work on the priority items first because we have to stick to our schedule and to the funded project, the cost of the project. So that's how we maintain the scope. We work on the priorities. So the product owner, along with the team, they work on the features or the requirements which are in product backlog and they prioritize it. So that's why I have shown in the picture as sequential numbers 1, 2, 3, 4, 5, 6, 7, 8. So this is a priority list. So the teams, once the priority is finalized by the product owner in the product backlog, then the team plans on that how much work they can do into their 2 week sprint. And this planning is called as a sprint planning meeting. So the frequency of the sprint planning meeting totally depends on the number of features we have in the backlog. Sometimes it is um, generally I have seen like sometimes I am doing 2 or 3 times in a week, and that's 1 to 2 hour duration. So in that, what we do as a team, we see all the features which are there in the product backlog, and we see how much work can be committed for a 2 week time. Out of those, we pick some tasks. I will come to a formal term here. These tasks can be either features. Features are broken down into form of user stories and further into the form of tasks. I will show you an example, then it will be able to you will be able to understand, you all will be. But what is happening here, the Scrum team is seeing the work, what is defined in the product backlog, and they are picking the work in their sprint planning meeting from that work to their own sprint backlog. So the sprint backlog consists of the work which is only required for that 2 week cycle. So they just pick based on the feasibility of those features, based on whatever the estimations. You can say that how much time it will took. So they do all the estimations about those features. Whatever they see that they can deliver in this 2 week, they pick that one. Because once you enter into the sprint, that scope cannot be changed. So once you enter into a sprint is 2 weeks, 15 days. From the beginning, you guys start working on that. The Scrum team starts working on that, which is analysis of those features or the tasks which have been picked up, then designing of those, the coding of that, the testing of those, and then finally delivering that. But meanwhile, because this is a very short duration, short cycle, 2 week, so every day we have a Scrum daily stand up meeting. That's called as a daily stand up meeting, where everyone, means like the Scrum team, talks about what they have accomplished in the last 24 hours, what they are gonna plan for the next 24 hours, and if there are any issues or risks they want to highlight to the team. Because when you enter into a sprint, it's totally is the responsibility of a scrum team to deliver that list of tasks. Commitment is the highest priority, so they cannot deviate from that. I have never seen any exceptions. So whatever has been committed is always delivered at the end of 2 week cycles, whether we are bringing extra resource or whatever it is, but we have to deliver what has been committed at the beginning of the sprint. So no changes are required. And after every 24 hours daily in the morning, generally, the Scrum team has their daily stand-up meeting where they talk about the status. And Scrum Master is the coach. He's the coach who facilitates the Scrum team and he helps them to follow the agile practices. Scrum Master is not part of a Scrum team. Please remember that. I have talked about here Scrum Master and Product Owner. We have three components, three roles here: Scrum Master, the team, that is the Scrum team, and the Product Owner. All three are different. Scrum team is only comprised of developers and testers, self-organizing team. That's it. Analyst can be there, but coders and testers. That's the Scrum team. Usually, it consists of 5 to 7 members. That's a fixed number. You cannot have 12 or 15 people, and not below than 5. So the standard size is 5 to 7 of a Scrum team. We have a separate Scrum Master whose role only is to facilitate the agile practices by the Scrum team. So he can only help. And Product Owner is the one who is giving the requirements. So Scrum Master's role is to facilitate all the Scrum activities which the Scrum team is doing into that sprint, that is of 2 week cycle. And in that 2 week cycle, it doesn't mean that there is no work done on the product backlog. So parallelly, the features are prioritized. That refinement process goes on during that 2 week cycle, so that when the team comes out of that 2 week cycle, they are ready with their next set of prioritized features. So that's a continuous activity which is going on through that 2 week process. So after that 2 week process, the review is done by everyone, like all the stakeholders, the engineering teams, the product owners, the scrum masters, the developer leads. Everyone comes into that review and they just see that what the team has developed, and accordingly the feedback is given to the sprint to the scrum team. That feedback is the retrospective. This retrospective is for everyone who was involved from the very beginning to the end, whether he is the product owner or the scrum master or any other architectural team, anyone who is participating in that. So they all come together after the 2 week cycle and they share that how they can improve, the efficiency of their sprint, like what they lacked. Because initially when we started with agile, nobody was sure that how we can do the work in 2 weeks, like it's a very small cycle. So retrospectives are very important. They give you a reflection of what you have done in your 2 weeks and how you can improve in your future sprints. So this is the whole process flow, how the teams work, how the requirements flow goes on, and how the sprint looks like. Any questions on this? No questions? And everything is going above? I know these things are very practical. Once you are into the framework, only then you can understand that. But I'm just trying to give you guys some overview that if you guys get any opportunity to talk to someone who is scrum master or product owner, at least you know that what is their role and how they work with the teams. If no questions, let's move forward. So I have already talked about the roles and responsibilities, the Scrum Master, Product Owner, and the team. So Scrum Master is the one who facilitates. So there is no development role of a Scrum Master. He's just like a coach. If the team member sees any issues or anything that needs to be taken to the customer, so he's the one who is an intermediate between the team and the business. And product owner is definitely our customer or representative of the stakeholders, and he is the one who gives the prioritized requirements to the team. And the team is again it's like 5 to 7 size, and it consists of like developers and testers, and they are like self-organizing teams. So whatever they have committed at the beginning of the scrum, the beginning of the sprint, so they have to deliver. So the commitment is the most important trait of the team, which is a self-organizing team. So these were which we have already discussed. The product backlog, sprint backlog, I think you guys are now should be familiar. Let me go back again for a second. So if you see, product backlog is the one which is owned by product owner on the left side. So this is the list of the prioritized features, and sprint backlog is the set of tasks or the features which are picked by the Scrum team for a particular sprint. So
Ma'am,
yeah.
previous slide. What is the work actually being done in product backlog refinement?
So backlog refinement means that's what the priority changing, that what the business thinks that what should be the priority of which feature should be on the top priority. So those kind of refinements, and if they realize that they need to bring up new requirements, so they add new features. So those all kind of
This is
activities.
inside the sprint, right?
Yeah, this is a parallel activity. See,
Okay.
sprint is not only for the Scrum team that they are just doing and developing and testing. So many other activities are also being done parallelly. See, if you see the diagram, there is a small cycle on the top, right? So that's a parallel activity, a parallel cycle going on. That is the product backlog refinement along with the total sprints. So
Got it.
then sprint burn down chart, I will show you actually. Okay, so this is sprint backlog. We have a list of features, or as I told that there is a term used, a story or the task. So we decide that these are the stories given and what I have to do, how much are in progress, and what is done, what is to be done for the testing. So this is how intermediate sprint looks like. When we go into a daily scrum meeting, which is every 24 hours, we present this board that these were the stories which were the part of the commitment, then these are in the process, then these are in the testing, and these are already done. So we just play with the cards that this is work done, this is in progress, to give the virtual more clear picture that how our sprint is looking like and how much we have achieved. Then again, in the form of this chart, the Scrum Master is the coach who also takes care whether the team is going on the progress or not, because it's a 2-week cycle. The product owner also sees that how the team is going on. Now, if you see here, there are blue bars and green bars. Blue bars are the ones which are the tasks which the team is doing, and the green ones which are accepted by the product owner. Like I told you that the product owner or the business is associated from the beginning to the end. So they also keep eye on what the team is doing, and parallelly, if they have whatever the task they are completing, they are nodding ahead. They are accepting that, okay, whatever you have done, we are totally accepting that. So the acceptance is at iteration level. So it's not like that in waterfall that you are doing all the acceptance at the end and the customer is not satisfied and then you are going back. So at every step, the customer is providing its acceptance, and this is showing at the end of the, if you see the last date, that is October 9. Okay, this is MMDD. So this is October 9, and you see that everything is accepted. The green bar is at the top. So the goal of the sprint is we start from the blue and we end with green. So that's how it works. So it's called as sprint burn down chart. That is how much we are burning from day to day. in our 2-week sprint. This is this is just for tracking purposes. And then again, I have already talked about that what are the different ceremonies, what are the daily Scrum meetings used for. It is just for the Scrum team to talk about their progress. Sprint planning is where the teams are finalizing what they need to pick for their sprint. The sprint review, where they are giving the demonstration to the customers or any stakeholders. And retrospective is where they are just giving a reflection back on how much, what they have achieved, and any feedbacks if the team wants to share with anyone. So again, in pictorial form, this is the same. The roles. Um, what is the role of Scrum Master? We have already covered that in daily Scrum, the Scrum team is the responsible one. And sprint retrospective, everyone participates. Sprint planning is where Scrum team participates. Sprint review is everyone participates along with the stakeholders. So everyone has their own role in the 2-week sprint, and all the meetings are associated according to the type of roles. Like Scrum team is the daily Scrum meeting, which is a 24 hours meeting, is generally only for the Scrum teams. It's not for the stakeholders or any engineering team. So it's just for the team. So if you see here how the change in accepted, on the left side, when we were selected only 2 tasks in sprint 1, and in sprint 2 on the right side, see how Agile handles the changes. So if you see in the sprint 2, there is a change comes up that the customer is giving us, the product owner is giving us, that there is a change 1, like change 1 is, you can say, the task, another name of task, that this is now more given the priority. So the only priority can change at the beginning of the sprint. So they can accommodate the new priorities which are coming into the product backlog during their refinement process. So any new priority comes up, the new sprint can accommodate those changes, but not in the sprint. Okay, I'll share some of the screenshots from the Rally tool, which is Scrum tool. I cannot share the live because we have the copyright restrictions. I cannot share my IDs openly here. So I have taken the screen captures here that will give you a good idea of how this works. And let me tell you, Rally, that software, that is used for Scrum framework. So don't get confused that this is helping us to develop the code. No, Rally, that is the Scrum tool or the Scrum methodology or Rally tool, they are just telling us how to do that. They are not helping us that how you want to develop the code. They are just directing us, first do this, then do this, then do this. So you can say that this is a kind of tracking, that first how we define the requirements. So we are the ones who are defining the requirements. Then they are saying develop the code. Then Rally is not helping us. There is no language. So the thing background is same, like you have seen that you are developing your code in Java or C++ or whatever language you are picking up. So the same thing is there in that, but the process is followed through a Scrum methodology. So Rally helps us to follow that Scrum methodology. That's why this tool is used. So let's go over that. Let me come. Okay. So this is the link. I'm hoping that this PPT will be shared to you all. So Rally, earlier I told that this CA Agile Central. So this is a licensed software, and companies have their own purchasing on that, so we get access accordingly. So, but this is how the login screen looks like. You log in with your credentials there, the organization credentials, the first screen of Rally. And okay, let me, okay, yeah, before that I want to show that what is the how a feature and user story looks like. So suppose I was just initially talking about that you want to build a site that wants to sell shoes. What can be the different components of that requirement? Like displaying information on the home screen, my user registration form, my user login form, displaying the products, displaying the shopping cart, and adding products to the shopping cart. So if the product is given to you or any vision is given to you by your customer, the first thing is to build the features, uh, the high level requirements. So the feature is you are breaking down the vision or the requirement of the customer into smaller requirements. Those are called as features, and those features are further broken down into user stories. So let's see let's see user login or user registration. Users registration is one of the feature which was identified, but that is further broken down into user stories. Like as a user, this is actually the format of how we write the user stories. So when we say that user registration is a feature, what can be the different parts of that module, the sub requirements of that. So it's further broken down into smaller requirements basically in user stories. Like in user registration, you are saying I need to be able to register as a new user, or I should be able to log in with my existing account. So these can be the different further smaller requirements from the user registration feature. So the process is you have a feature initially, you can say first you have a vision from the customer, those are written down into the features, then those are written down into the user stories, which are again the smaller requirements, and those are further broken down into tasks. So the task is the smallest work which is done by the scrum team. So this is how the structure of the requirement goes from the vision to the task. So I'll just give you a glimpse here. See this one now. This is our portfolio Kanban, which is, if you'll see on the very top, on the right side of the portfolio Kanban, there is a word written there, initiative. So we can see the portfolio or whatever you want to see in Rally, either from the customer point of view or from the team perspective. You can select from the drop down. If you want to see the initiative or the vision which was given by the customer, you can select the initiative. If you want to see the features, you can see the features. If you want to see the user stories, you can select the user stories. So this board will keep on changing. So if you see here, this is giving you what is no entry. No entry is representing here backlog, that it is not lying in any sprint right now. So it is in my backlog. The team is working on discovering it, that how they will be working on those features which are presenting in no entry. So they move the change, they move the state of that. What do you do? These are all cards. I think I showed you one of the diagrams where I was showing you the cards. So what do you do? It's a simple drag and drop. So Rally is giving us the provision of working in a Scrum methodology. So it gives us some kind of, architecture or framework, which is helping us to define the requirements in different phases. So when we say that my feature is in no entry, and I have started working on it, so I will move that from discovering to developing. I'll just simply drag and drop to that. So that way the state of the feature will be changed to now in developing, and then in measuring and to done. So this is how we play work in our regular tools, whether it's SQL or Oracle or any language, but this we use to track and how we are following the Scrum. So this is a very particular view. And these are some of, okay, this is not much important for you guys. Okay, yeah, now see this one. So now these are milestones. If you see, just focus on the right column, milestones. So these are defined by the customer. So milestones is that a customer wants that they want some TCS demonstration, or they want some piece of code to be delivered on Labor Day. MVP is minimum viable product. So if they have some milestone that they want to deliver this piece of code um, on this particular day, so they set a milestone. So the teams work based on their milestone. So to achieve that milestone, what are the features which need to complete? So they associate those features into those milestones. If you see on the left side, we have features which has the naming convention of F, stands for feature. So if you see F140, that is feature 140, that belongs to two milestones, Labor Day and MVP. That means there are two milestones for which this feature needs to be completed. So that's how we are tagging the expectations of the customer based on what their priority is, that they want Labor Day and these features to be delivered. So we are just categorizing that these features should go into this milestone, these features should go into this milestone, so that we can track the features. So this is how we do as per their priorities. This is again, if you'll see here, this is now talking of the features in very detail. If you look closely to the columns here, I know the size is small. So it says the feature name, when it is planned, what is the status, whether it is in the developing state or the validating state, and how much it has been completed. So like 38% or 74% or 82%, how much it has been done, and by which team, that is the last column. So this is a very typical view of Rally to track the features, that how much they have progressed and what is the state of them. Again, we can show the dependencies. We can select the releases, that when we want to release these features. If you guys see on the top, there are iteration 5, iteration 6, iteration 7, iteration 8. So that is representing sprints. So which features I want to release in sprint 5, which features I want to release in sprint 6, sprint 7, sprint 8. So there is a continuous number going on. When one sprint completes, we go into sprint 2. When second sprint completes, we go into third sprint. So for a year, like for 2020, as this year is ending, so the sprint number also ends. Every year we start again then with sprint 1, sprint 2, sprint 3, like that. So when we do the planning, so we decide that which features should go into which sprint and what is the priority according to the priority of the customer. Then here you can see the capacity. See on the right side, the capacity of the team is given here. Like suppose if I'm saying Diwali is coming up, and in my Scrum team, out of 5 resources, 2 people are on leave, so the capacity gets reduced. Like if my team is 100% available usually, but during Diwali time, my team is only available of 50% of my capacity, so they pick work accordingly. So this is how to see that what is the capacity of the team and how they are picking the work, so that expectation of the customer is also there, that okay, they understand, okay, this is Diwali time, so I will not expect any deliveries because the capacity is small at that time. So Agile is totally transparent. Everything the team is doing, what their capacity is, and any issues, dependencies, always visible to the customer. So this is more detail. Okay, so if you'll see, we have 4 options there: planning, tracking, quality, and the reports. Planning is where we play with the features and the user stories. If you see the options in the plan, like user stories, what are the user stories, and how the team is planning where they can pull the features that which should go into which sprint. Then in the track, we can see, as earlier I was showing you, how we are tracking that how much work is done and how much work is pending. So all you can do that in track. And then in quality, we have the test cases. So the test cases are into this menu quality. Let me show you that one. This is tracking. Yeah, this is okay. No. Yeah, these are the test cases. So if you see that quality as highlighted on the top, so this is all the test cases which the team is planning for that particular features or the user stories they want to execute in that sprint. So these are all the test cases. It's all written here. They can go and create the test cases, and once it is executed in whatever the tool testing team is using, they can come here, they can mark it as completed, and if there are any defects found, they can log the defects also. So these are the defects. If they found any test issue in that, so they can come here, log a defect into the defect suites. So the team will then track, and accordingly the actions will be taken. Then multiple reports are generated from Rally tool, from the progress perspective, from the team track perspective, from release tracking perspective. So there is never a need of creating your own reports. It's all automatic because you are planning, tracking, and maintaining the quality everything in Rally. So based on your updates you are doing in like features, like if feature is done or in progress, based on that these reports are generated automatically. So we don't need to put any extra effort here. We just go here and generate the report and see the progress like this. So these are the different formats based on the customer's requirement. If they want to see from the release perspective, if they want to see from the pending work perspective, they can just simply go there and see the different kind of reports we have available. Plenty of reports are there in Rally, and that's why it's like a full-fledged tool which is adopted by most of the organizations because it's giving everything and it's making life very easy to follow the Scrum. So I hope I have helped you guys to understand some of the Scrum concepts and how this Rally tool works. And it's not like, I will say again, it's just for tracking and maintaining the things and writing the features and everything. But actually, when you are coding, you are doing in your tool, whatever the standard tools are used for testing or coding. So it's just for following the Scrum methodology. So before we leave, I just wanted to give you the familiarity of this name. AHA. Now, when we are talking of Rally, that was the tool which was used for implementing the Scrum for them. But when we talk from the business perspective, they are just writing the users, they are just writing the requirements in the product backlog. But nowadays, this has started coming into the organizations that business should also use their separate tool so that they can maintain their own requirements, they can see the progress of their requirements, and they can play along with that, but not in Rally. So we have a very good integration between AHA and Rally. So what is happening in AHA, what the business thinks, it's only usable by business. So the business is just writing their requirements in this AHA tool. So it's their roadmap tool. Whatever they want to plan, whatever they want to prioritize, it's not in Rally, but they are now doing that in AHA. So that's why it says that why, when, and what. Why they want to do it and when they want to do it, like what will the schedule and timelines, and what will be the release and features they want to get delivered. But the how part, how it will be done, how the features will be delivered, those will be done by the engineering teams, and that will be done through Rally. So whatever AHA is capturing is only from the business perspective. I'll just show you one or two slides on that. I think I should be done with that. So see, this is a very high level where strategies are added, that what is the goal and what is the initiative from the business perspective. They set the timelines, that what will be the releases they are expecting, and then they define the work accordingly, that for those releases what will be the features, and then those are going to the integration with Rally. That those features which the business is expecting in a particular release. So we sync the data, we have an integration with Rally. So whatever the features which is defined by the business team is directly going to the product backlog in Rally. So they don't need to, business don't need to use Rally now. So they are now moving to using their own tool, which is AHA. And this is just only for business, only for customers, so that they don't need to write on their spreadsheets or, any other kind of format. They can also use a similar Scrum tool or framework, which is AHA, and helping them to prioritize the requirements and creating the roadmaps. And again, like Rally, if you see on the right side, there are two more options there: roadmaps and analytics. Like in Rally, there were so many reports which we could have generated from there. So the same analysis we can do from AHA also. I'll show you. So yeah, like this one. So this is a kind of a feature board for them. Now this is AHA. This is not Rally. These are the features which they are expecting from their teams to do. So these are all the features which are like in under construction, in design, and ready to develop, and in development. So there is an integration with Rally. So when the team starts work on a feature, automatically the status gets updated here, because ultimately the development work is trackable in Rally only, but the status is reverted back into AHA, that what the features the team are working on and how much work they have completed. So everything is in sync. So whatever it's done in AHA, it's going to Rally, and whatever the Rally is doing, it's coming back to AHA, so that customer can see what the teams are doing. So this is how they are doing the release tracking. And just wanted to give you a glimpse of this, that how these roadmaps and all looks like, that what they are planning for Q1, Q2, and Q3. Based on that, they define the features. Yep, that was pretty much. Any questions? I know that was a lot to grasp. I would love to see all your questions, and if you are not comfortable to answer questions right now, please email me, or you can take the email address from your faculty. So I'm always happy to answer you guys. Any questions?
Yes, any query, participants? I think they have interacted a lot during the sessions.
Oh, okay.
I'll share your email ID with them. They
Yeah,
can
sure.
contact you anytime.
Yeah.
So, Dr. Niharika, I would like to thank you for this lovely talk on agile technologies, and I hope our participants, they also enjoyed it a lot. Thank you very much, Dr. Niharika.
Thank you all for listening patiently for 2 hours. So yeah, any questions, please email me.
Okay. Thank you, participants.
All right. Thank you guys. Have a nice day. Bye-bye.
Bye.